In this lesson, we are going to learn how to structure your code for more bigger and more complex projects. Currently, we have been doing some small code with simple separation of the different parts of the code, like we have the loaders, the base, something about updating the material, the environment map, and we just separate with comments. I call that spaghetti code. I don't know if it's something or I just heard it somewhere, but you put everything in one file and you have to scroll. It's not ideal for bigger projects because first it's hard to find what you want. You need to scroll a lot, try to remember where it was. You can hardly reuse specific parts because if, I don't know, you take, let's say the fox, well, you will not just take the fox, you also need to take the part in the tick function. You will have conflict with other variables, especially with common variables like I, j, and simple variables like that. You will have conflicts with other developers if you do work with a team of developers because everybody will work on the same file. Imagine doing that while versioning your project. And obviously you will have some crumbs to your finger because you spend your time scrolling and that's bad for your health, etc., etc. So we need to do something about that. We are going to use classes and modules. You might think, oh no, I don't know about classes and modules. Do not worry, we are going to learn those here. If you already know classes and modules, well, maybe you can accelerate the video. So right below, you can do that on the player. If you don't know about classes and modules, I'm going to explain everything you need for this course and even a bit more. All right, by the way, what I'm going to show you are personal preferences. Initially, I wasn't supposed to add this lesson to the course because the way I code is very personal and I know that many developers don't agree, just like I don't agree with their way of structuring their code. So it's very personal and you should take what you think is good and get rid of what you think is wrong, and you should create your own template. We're not going to use that structure in the rest of the course because you will see that it's a bit complex, and we will keep everything simple in the following lessons, and we will keep using spaghetti code. All right, it's up to you. You can start using the structure I'm going to show you even for the next lessons, but in order to focus on the topic of the lessons, we are going to do spaghetti code for the rest of the course. All right, let's talk about those two concepts I talked about, which are the modules and the classes. And we're going to start with the modules. The idea of the modules is to separate our code into multiple files and import them when we need. All right, currently we have everything in the script.js file. I mean, all the JavaScript in the script.js file. Then we have the HTML and CSS. Okay, we're going to split that in multiple files and we are going to import them when we need them. That's the idea behind the modules, making things very simple. Actually, we are already using modules. When we import libraries like Three.js or .GUI or GSAP or whatever, we are using modules. All those imports you see at the beginnings are modules. And we are going to learn how to create modules now. Those modules are being imported from the node modules. We are going to create files that we will put on the src folder, import them from here. Okay, so what about compatibility? When we use Webpack, all the JavaScript, so currently you can see that we have some imports and everything, all of that will end as one file, one JavaScript file with everything in it. It's a bit more complicated, you have source maps and things like that, but the idea is that those imported code are merged into one file. And it's great because we don't care about compatibility. It's just one JavaScript file. So that's cool. But be aware that modules are natively supported. It's been a while. Most modern browsers do support them, and you don't need a bundler like Webpack that handle modules. All right, so you can do that natively. It's a bit different. You can't do everything we're going to do now, but still you can use modules in a native JavaScript with Chrome, Firefox, etc. We are not going to use the native support. First, because it's not compatible with everything. Like if I show you on the can I use page, as you can see, some old browser doesn't support, like Internet Explorer obviously, but even some old version of Edge, some old version of iOS do not support them. Actually, don't worry, you can use them, but let's make everything as compatible as possible. And the next reason is that we are already using Webpack. I mean, Webpack natively support modules. We need Webpack to handle the dependencies, to handle the dev servers, things like that. So we need Webpack. Let's use modules from Webpack. Okay, cool. Let's talk about the syntax. I'm going to close this one. By the way, here's my scene. It's quite a simple scene. We're going to talk about everything in that in details and move everything into modules and classes I will see later. So that's what the project we're moving into. That's a code structure I'm showing you. But first, we want to talk about modules. We're going to comment everything, okay? Right now, we are not doing Three.js. We are not doing this animated Fox in WebGL. We are just trying to learn modules. If you already know about modules, maybe you can skip this part. So I comment everything. So I get a white page, no error, that's cool. And we're going to create another file. And this file is going to be named test.js file. And it's inside the src folder, as you can see here, okay? So I have my script.js on the folder, and now I also have the test.js file in that folder. That test.js file is going to export something. All right, we are going to talk about that something. And the script.js file is going to import that thing. So let's go. A module can export one or multiple things, but to keep things simple, I like to export only one thing per file. So again, that's kind of my personal preferences. When I create a file, this file, we only export one thing, so that everything is simple. You see the many files in the folder, you know that each file is going to export one thing. We're going to learn how to do both. And we start very simply by writing export default. So I'm on the test.js file, and I write export default, and then I'm going to export a simple string. Hello modules, just like that. So I saved, nothing is happening because the main file, the entry file is script.js file, and there is nothing in that one. In this script.js file, so I can keep the whole code commented. We will get back to that code later. I'm going to import what's inside the test.js file. I'm going to do import. I choose a name. It can be like test or whatever. Actually, you can put anything you want currently. Test from, and we need to write ./test.js. Be careful, the ./ is very important. If you don't put that ./, it will try to find it in the node modules. Just like when we import Three.js, it's just Three.js. It's not ./3. All right. So be careful with that. This is a relative path from the script.js file. And then we can do whatever we want with that. And you can guess that we are going to find the string we've been exporting. So I can put it below so that you guys can see both. I export the string and I get it from here. I can change the name to that. And it's going to work too. So currently we can choose the name of what we are importing. Okay, that's the base. It's almost everything you need to know in the way we are going to use it, okay? We are going to go a little further to know more about modules, but that's the main part. You can now import and export stuff from different files. That's cool. You can export more. So as you can see, this is the default export. We're going to talk about that later. We exported a string, but you can export, let's say, a function. So we can do a function like this. And we can do the console log hello module, so it's kind of the same thing. And I can use the traditional function, or I can use a factor. It gives the same result. So I'm currently logging this function, but because it's a function, I can simply call it. So with the parentheses like that. Okay, that's cool. So we kind of encapsulate the code inside of that. We can do many things inside of that. And here we import it. By default, we do nothing, and when we want to use it, we just call that function. That's cool. So we can export a string, a function. What else? Well, we can export an object. So export default an object and put whatever we want with that. Hello modules, why not? And then here we can import it, and if I log it, well, I get that object, and because it's an object, I can access to the properties. And now I have modules because it's inside the hello property. All right, cool. No surprise here. We can also export classes, and we are going to learn about the classes right after. Okay, so I'm not going to show you the classes right now because we are going to learn those later. By the way, the export instruction can be done after, okay? I like to do the export immediately because I'm just exporting one thing, so I create that thing here and I export it immediately. But if you want to create, let's say, something to export, you can call it whatever you want. By the way, you don't have to do those things. Maybe you can just follow what I'm saying, because we are going to erase, delete everything after. It's up to you if you learn just from following the instruction, or you need to practice to learn, so it's up to you. But we are going to delete all of those. We are just learning those concepts. So I created the object. So currently my test.js file is not exporting anything, and later I can do the export default and then that object, okay? We get the same result. Sometimes you will see one, sometimes you will see the other. You will see that in my way of structuring the code, we do export default and we put the class, that famous class, directly at the beginning. Also, one file can export multiple things. How to do that? First, in the JS file, we're going to, let's say we change this one to one thing. Okay, so one with an E thing. And then we create something else, another thing. And it can be something else, like another type, like this one is an object and the next one is a function. This other thing is going to do whatever you want, like say hello, so hi. And then we are going to export and we are going to get rid of this default. Okay, so we are going to export like that. We kind of send an object, okay, and we do one thing, comma, another thing, like that. So right now, this script is exporting multiple things, but we are importing by assuming that there is only one thing. So we need to do some changes here too. The syntax is a bit different. We need to put back those curly brackets here and write the same thing. So one thing and another thing, like that. And in the code, in the following code, we will have a variable name one thing and a variable name another thing, which is exactly what we have in the test.js file. So I'm going to push this one further away. Okay, so we can log this one thing. As you can see, I get the first one, so this one. And if I log the other one, well, I get that function we created, so I can call it, if I want. Another thing with a G, like that. Okay, it's working. You don't need to import everything. And that's the cool part when you export multiple things from one file. You can choose to just import another thing, like that. As you can see, yes, we have access to one thing if we want, but we just retrieved the another thing. Okay, that's cool. And actually, we can do that with Three.js and many other libraries. We have not been doing that for now, but in Three.js, you can import. So usually we do import everything as 3 from 3, like that. And we get all the classes available right here. Modules, and here you have all the classes, the geometries, the cameras, the WebGL renderer, etc. But you can also write like this, just like we did. We import just a very specific part of the Three library, and we get the exact class we need. And this is sometimes better for the tree shaking, which is kind of a technique that consists of removing unused parts of a library. It depends on the tree shaker, but sometimes it's better to use this system, and you will end up, if you have a tree shaking, with a smaller file. Okay, I'm not a big fan of that, because in the end we end up with many classes at the top of the file, and you have to always jump at the top, remove the one you don't use anymore, put back the one you use. So I tend to just import everything just like we did before, like that. But you can do it, it's up to you. And that's all for the modules. Easy. Now let's talk about the classes. I'm going to remove what we already did. So we are going to export and import classes. Yeah, that's the idea. Classes allow us to use the object-oriented programming. All right, that's something you can find in many languages, programming languages. JavaScript do support object-oriented programming. It's a bit weird compared to other languages, but still it's working. You can do some OOP in JavaScript using those classes. Let's talk immediately about the compatibility. Classes are supported by most browsers, browsers, as you can see here. So we don't have a lot of issues, kind of a bit better supported than the modules. Anyway, you can just use them. You won't have issues unless your client is in a very old computer with a very old OS and a very old browser. So yeah, we can just use them. But how do we do that? What's the syntax? First, we are going to get rid of what we did with the modules. Don't worry, we're going to use the modules again right after. But for now, let's get rid of that, so in the script.js file, and I'm going to get rid of the test.js file. Okay, we are over for now with the, we are done with the modules. Let's talk about the classes. So how to create a class? It's very easy. It used to be super hard. We had to use prototypes and use function as classes. I mean, it was really weird, but now it's currently very simple. Though it's just syntax, it has become very simple those past years. This is how you create a class. And as you can see, I just put class space, the name of the class, and that looks like an object. So it's not an object, but it's curly brackets. Other languages do use this kind of syntax. By the way, the name of your class, for the name of your class, we tend to use Pascal case. You can call it whatever you want. I can do something like that with uppercase or lowercase, but for classes, we tend to use Pascal case classes. It's just a convention, you do whatever you want. But if you don't want to make enemies, I recommend you to use Pascal case. So we created a class, that's cool. If I refresh, I get nothing, because I just created a class and I'm not using that class. So let's go, how to use the class. A class is like a blueprint. We can use that blueprint to create objects, right? You have your blueprint on how to create a house, and then you create a house using that blueprint. And you can use that blueprint to create a house and create the house again and create the house again, and you end up with a village. So that's cool. That's the idea. So instead of creating some random classes, we're going to talk about robots. You will see that it will get handy a bit later to understand at least. So we create a class named robot. Cool. Now we want to create something from that blueprint, from the robot blueprint. We have a blueprint for robot. We want to create the robot, because that's not the robot, it's the blueprint of the robot. To create the robot, where we create a variable and we do robot equal new robot. And that's all. And we can save, so nothing is happening. We can log it if we want. And if you log it, you will see that you know that it's from this class, and that's all. You just created your first class. And as you can see, it's not that complicated. We create the class by doing new robot, just like we created, I don't know, a scene by doing new 3.scene. All right. We can create an image by doing image equal new image. This is some native JavaScript. You can create audio context. That's something else in JavaScript. I don't know if you know about that. Audio context or something like that. I don't know, maybe there are some parameters. That's the idea, but currently we are creating our own class. Let's move on. The robot variable is what we call an instance of the class. Try to remember that. This is the class. This is an instance of the class. I will use this term a lot. We can create multiple instances of that class, just like we can create multiple houses from one blueprint. We can create, so one robot. Let's change the name. We are going to create Wally. We're going to create Ultron, some robot names. Use those if you are doing the exercise with me, because they have very specific things that we get handy later. And then Astro Boy, like that, new robot. By the way, we are using Pascal case for the name of the class, and we are using a camel case for the name of the instances. That's just conventions. You do whatever you want, as long as there is no conflict. So that's great, but currently, our class is not doing anything, and our robots, so our instances of the class, can't do anything. So that's a bit sad for a robot. Let's add functions to our robots. To do that, so by the way, you can add some line breaks. Some people like to do like this, and I like to do like that, because I like when the curly brackets are vertically aligned. When you have a lot of code, it gets really handy. It's up to you. And we are going to add a function inside of it. To add a function, you have to write it like that. I save, everything seems fine. I can put something in there. So we can say that when we want the robot to say hi, we just log something, so say hi. We could have played a sound or whatever, but currently we're keeping things simple and put everything in the console. And I'm refreshing and nothing is happening because yes, now my robots can say hi, but I'm not asking them to do that. Functions inside of a class are called methods. All right, let's use the right terms. This is a function in the class. We call that a method. Okay. And every instance, so this is an instance, this is an instance, and this is an instance of the class, will have access to those methods. And we can do, I don't know, like Ultron, say hi, like that. And now Ultron just said hi. We can do Astro Boy, say hi, and now they're both saying hi immediately after being instantiated. And we can do that like here or whatever, it's the same as long as the variable is available. Okay, that's great. It's a good start. Now we want the robots to say thank you to their creators when they are being created. Why not? Let's discover more stuff with that robot things. If you create a new method and you call this method constructor, like that, as you can see, the color might be different. If it's not the case for you, do not worry. Make sure you wrote it well, so constructor. And if the color is not like mine, different from the say hi, it's fine. And you put something in there, I don't know. As you can see, those logs appear as soon as the class is being instantiated. Okay, so here you can say, I mean, you can log thank you creator. They are thanking us for being created. If you name your method constructor, when you instantiate the class, this method will be called automatically. That's the idea, and we're going to use that a lot. This method can have parameters. As an example, we're going to save the name of the robots when we create them. So what we're going to do is here, when we create the classes, we are going to send something. We're going to send the name of the robot. So this one is Wall-E, this one is Ultron, and this one is Astro Boy. You can put whatever you want if you want to create your own robot or whatever. So I saved, nothing is happening, but right now I can retrieve those parameters in the parameters of this constructor method. So we can put something like name. And what we can do, let's just log it to start with. As you can see, we get the Wall-E, Ultron, and Astro Boy. So those parameters. So we can do something a bit more funny, like we can do some concatenation in here and say, I am, so the name of the robot, thank you, creator, something like that. And now they are all, when being created, they say, I am Wall-E, thank you, creator. Let's put a point at the end. Okay, that's cool. Let's move on and let's talk about the context, because we are going to need this one too. We want the robot to provide his name when he says hi. Okay, so in here, so they are providing their name when they are being constructed, but we also want them to say their name when they say hi. So in there, like something like, I don't know, like, hello, my name is the name of the robot. So how can we do that? We could send the name again in the say hi. Don't do it. Like if I provide the name here, then it means here I have to provide the name again and the name again here. So I already gave the names when creating. I need to give them again. And we do my name is, and we do this thing there. We need to use back quotes like that. Okay, it's working, but I mean, that's bad. We need to provide a name every time we use it. That's not a very handy code. So let's get rid of that and let's do things a bit differently by using the context. Initially, we already provide the name. What we want is the robot to remember their name. We can do that with the context. The context is this. You need to write this, like that. So this And this, we can do something like this, name equal name. So the name sent as a parameter, we save it in the context by doing this dot whatever you want equal name. We can change that like a robot name or, robot name or the name or whatever. I'm using the same variable name because it's logical, but you can put whatever you want here. And then let me see. Yes, here we can replace. So instead of using the parameters, it gives the same result. I mean, this one is working, but here we can do this dot name like that. Okay, so it's kind of working. We can change it, but we can also access it. And now we can also access it from other methods. This is what we call the context. Let me check. The class is the same. Oh yeah, the class currently is the same for every instance, but the context will be different for every instance of the class, meaning that this, in the case of Wally, it's this instance, but this, in the case of Ultron, it's Ultron, it's not Wally. And this, in the case of Astro Boy, it's not Wally, it's not Ultron, it's Astro Boy. So this refers to the current instance. Even if it's the same code, the same class for every instances, this is the current instance. So it's the robot itself in our case. And yes, as I was telling, we can use it now in other methods. So here we are going to replace with back quotes, hello, my name is, and we can find the name back by doing this dot name. And if I save, hello, my name is Ultron, hello, my name is Astro Boy, and it's working. So this is how you save stuff to be used later in the class. You use the context. By the way, name in our case is what we call a property of the class, and we can access those just like we can access the method say hi. We can also do, let's say, let's use Wally. I can do log Wally dot name, okay, and we get Wally. That's this one, and we can do Ultron dot name. Those are properties. Okay, let's get rid of this one. A lot of words, a lot of terms. Property, classes, instances, context. So, by the way, yes, we can add more properties. Let's move this thing a bit further and let's decide that, well, some robots have 2 legs, some have no legs. We could have created robots with more legs, so let's save that. So as the second parameter, when you create a robot, we decide on how many legs they have. So Wally doesn't have legs. He has some, I don't know how you say, we say chenilles in French, those things like the tanks. The Ultron has 2 legs, right? And Astro Boy do have 2 legs too. Those, they are kind of reactors to fly, whatever. So 0, 2, 2. And then we can save those. So again, we are going to do, well, legs, and then we are going to save those to be used later. So legs equal legs. And then you can do whatever you want. I think we don't do anything with that. Anyway, we have those. You can do whatever you want. If you want later to test how many legs, I don't know, like it's a theme park and for robots, and you need legs to do this attraction. Well, you test, does the robots, so does Wally has more than 2 legs? Wally legs superior than 2? Yep. And as you can see, it's not going to work because Wally doesn't have enough legs. But if we test with Ultron, well, Ultron, oh, sorry, superior or equal to 2, Ultron can do the attraction. Oh yes, by the way, so I'm going to get rid of this one. It was a weird example. Anyway, you get it. We can also call methods from inside the other methods. So from the constructor or from the say hi. If I want the robots to not have to ask them to say hi, we can just call this dot say hi from the constructor or whatever method we want. And as you can see, I am Wally, thank you creator. Hello, my name is Wally, so it's a bit redundant, but you get it. I am Ultron, thank you creator, and automatically the say hi function is being called. Hello, my name is Ultron, and same thing for Astro Boy. Let's go even further because we need it. Let's talk about inheritance. Inheritance is like creating a class based on another class. just like we are creating a blueprint based on another blueprint. You have the blueprint of your house, and then you create a blueprint of your house, but with one more floor or a tower or better windows or whatever. That's the idea. So it's going to base on the first class and add stuff to it. Here we are going to create a flying robot based on the robot, because as you can see, we have 3 robots. One can't fly and the other 2 can fly. So it's a good example. So let's go. After creating the class robot, you're going to create a new class, which is going to be named flying robot. Again, you can put whatever you want here, but let's follow the lesson. And this class is going to extend the first class. And that's how you do the inheritance. And that's as simple as that. We have the robot class. We are using the robot class. And now we create another class, and this class is based on those classes. And what we can do now is change, well, for Ultron and for Astro Boy. And now it's still working. And as you can see, we still have the I am Ultron, thank you creator, hello, my name is Ultron, and the same thing for Astro Boy, even if this class is empty. Because this class, Flying Robot, is based on the robot, and the robot do have a constructor and a say hi. So the Flying Robot do have constructor and say hi. That's cool. But as you can guess, we're going to improve the class, improve the Flying Robot class, and it will add stuff to that class and not the robot. Let's say that our flying robots can take off and land. Why not? So take off, something like that. And we're going to just do some logs. Obviously, we don't have any, we have nothing on the screen, but maybe you can have like a 3D robot taking off or whatever. Have a good flight. Yeah, why not? And we provide the name of the robot. And then we can do the same thing when we want the robot to land. So land console.log. Welcome back. And the name of the robot, this.name. Okay, nothing has changed. Let's see if we can use them. Astro Boy is based on the Flying Robot class. So it's an instance of the Flying Robot class. I can do Astro Boy take off. Have a good flight, Astro Boy. So it's working. That's great. As you can guess, we can do the same with Ultron. It's working. Have a good flight, Ultron. We can do the land. It's landing. That's great. But we can't do it with Wall-E, because Wall-E is based on the robot class, not the Flying Robot class. And as you can see, we get an error. Wall-E land is not a function. That's great. That's all. This is how you use inheritance. There are some subtle things to discuss, but that's the idea. We can override the base function. Like, let's say that the say hi function, when it's a flying robot, we want it to be a bit different. So I'm going to write the same name. I'm going to do, let's get rid of Wall-E. Let's use nothing actually. And I'm going to use the say hi method. It's the same name, okay? And I'm going to do something else, something like that. And as you can see, for Wall-E, we still have the initial say hi, but for those two, so Ultron and Astro Boy, now we get this. The function has been override. Okay, cool. So we can put something a bit more interesting. I'm going to copy because I'm a bit lazy. Like that. Hello, my name is and I'm a flying robot. Why not? Hello, my name is Ultron and I'm a flying robot. Hello, my name is Astro Boy and I'm a flying robot. So yes, it's redundant, but you get the idea. If you want to do it for the constructor, you will have to do things a bit differently. You have to start the method with super. Let me show you. I want to do something else in the constructor. Constructor, oops, see, I wrote it wrong, not the right color. Like that. Just that. I'm just writing constructor and I save. And as you can see, we get an error. Must call super constructor in derived class before accessing this or returning from derived constructor. So the message doesn't help much, but I can tell you what's wrong. When you are using constructor, you can't just override it like this. You need to provide super. You need to call super. I'm going to talk a bit more about super. And as you can see now, it's working. And we did override the constructor. Super is a reference to the base class, so the class above. Super corresponds to the base class, so in our case it's robot, and using super like this is calling the base constructor so that everything we do in the base constructor will be done in the new class. Okay, so we just call super like this and it's calling that. And we need to also provide the things, the parameters, because currently, as you can see, hello, my name is undefined and I'm flying robot. I am undefined. So there is a bug because flying robot, we provide those parameters, but in our constructor, we don't have those parameters anymore. So there's a bug. And here we say that we call the initial constructor, so this one, and we still don't provide anything there. So we need to provide the same things in the case that it's what we want. So we need to provide the name, the legs, and we need to kind of forward those to the initial constructor like that. Now we get the name back. So be careful with the constructor you need to call super. Super is a reference to the base class. Okay, cool. By the way, we can use super to call methods from the base class like this. Like if I want, let's say, initially let's say that initially the robots don't say hi. Like that. So I am Wally, thank you creator. And we want the flying robots because they are better to say hi when they are being created. So here what I can do is super say hi, like that. And as you can see, they do, hello, my name is Astro Boy. They don't do this one. If it was this one, they would have said, and I am a flying robot. When we use super say hi, like this, it's referring to the base class method, not the current class method. If we want to use the current class method, we can do this say hi. Now they say hi. If I do super say hi, it's going to be from the base class. We usually don't use that. Me, I never use that because I know how to use that. Sometimes I can get use of it, but I will not because it gets super complicated for someone else arriving on my code and thinking, what the hell is that? Why is it not calling the say hi? Why not this say hi? If you create a method, you're supposed to call it. So I showed you that, but usually we don't use that kind of thing. We just need to do the super here if we want to do more in the constructor of the new class. Okay, great. It was a bit too far, but still we are going to need some extends and do the super just like that. Okay, great. So we learned about modules. We learned about classes. Now we are going to merge those, and don't worry, there is no surprise there. Let's go. We are going to separate our code into files, and each one of these files will export one class, so a different class. Let's open the sidebar, and we're going to create a class. So it's going to be the robot.js. I'm inside the src folder, and in that robot.js, I'm going to take the robot, not the flying robot, just the robot. I'm going to cut it and put it in that file. And in that file, I'm going to say that I want to export that class. Okay, so I do export, and it's the only thing to export, default. So right now, robot.js file is exporting a class. Then we can do the same for the flying robot. So flying robot.js. You can name them differently. Some people like to do flying robot.class.js. I'm kind of thinking that if it's in Pascal case, well, it has to be a class, so it's up to you. And we put the flying robot there, so the class of the flying robot. So I cut it. That's all I have left in the script.js file. And inside the flying robot.js file, I passed it. And again, I do export default class flying robot. But I made a mistake. Can you guess what is missing in that file? The flying robot is extending, so inheriting from the robot class. But where is the robot class? It's in another file. So inside this one, we need to do import. So it's right after. Right here. Import robot from, and it's inside the same folder. So robot.js. And now we have access to this class. We can inherit it from this robot class to create the flying robot class, and we export that class. Yeah, it's a bit far-fetched, but you get used to it quite fast. And if you would have forgot, don't worry, the console would have said, I don't know what's the robot class, and you would have understand quite fast. Okay, now we can get back to the script.js file. And now here we need to import the classes we need. So we need the robot class and the flying robot. So let's go. Import robot from ./robot.js. Oh, by the way, the .js is optional, but I find it really weird to have this optional. And I want to make things clear that this is JavaScript. This is not something else, because in Webpack you can import CSS or anything that you have set in the rules. So for me, it's not logical to not put the JS file. And then you can put but you can do whatever you want. The flying robot from the file flying robot.js. Did I get something wrong? Robots, flying robot. No, I think everything is fine. We save and everything is still working. And now you can see that it's cool because things are being separated. You work on the robot, you just work on that file and you create the blueprint, that will be used by you or other developers, or maybe like in many years, people will keep using your library or whatever. Then we create a flying robot based on the robot, and it's just the code for the flying robot, and everything is well separated inside methods and properties and things like that. And then in the script, we use those, and the code became very simple. We import the robot, we instantiate some robots, we import flying robots, we instantiate some flying robots. Not too much code, no spaghetti code, at least. Okay, great. So yeah, at first, all of this might seem a bit complicated, but your code will become much more maintainable, just like I explained to you. And you will be able to reuse that code too, like if you want to reuse the robot on whatever project, though it's a bit weird class that's not really useful, you can create more useful classes. We are going to do that right after. Well, you can. And it's going to be much easier. So we learned about modules, we learned about classes, we now know how to structure everything. It's time to structure our project. First, let's remove everything we did with the robot. So I'm going to remove this. I'm going to remove the robot.js file. Those were just examples for the sake of learning. We can get rid of those. You can put them somewhere if you want. We are going to have a quick look to the project. You don't have to do this because I'm going to comment them again. I just want to show you what we have in the project. So as you can see, it's a fox, animated fox. That's interesting. You can't see much of it, but we have an environment map. See, I can change the intensity. We also have a light, so everything reacts to light. We have some shadow. I just used that GUI, so we need to instantiate that GUI too. And we have some orbit controls, and that's all. So quite a simple project, but obviously the code we are going to do will be handy to create much more complex projects, as you will see. So I'm going to comment everything again, but not the style.css. Do the same, you can comment everything, but not the style.css, because we need the CSS. Okay. Actually, you can remove everything. It's just that I like to keep this. When I'm converting some spaghetti code to classes, I like to keep the initial code there so that I can move things progressively. It's up to you. So what I like to do, I think it's a good practice, is to put the whole experience inside a main class. And that class will create everything else. And I like to call that class experience, but you can call it whatever you want. If you're creating a game, you can create a game. If you're creating, I don't know, some robot farm, you can name it a robot farm game or whatever, maybe application, WebGL application. It's up to you. But me, I like to use experience. So to do that, we're going to create everything related to the experience inside a specific folder. So follow me on that. In the src folder, I'm going to create a folder named experience. A folder named experience. And in that folder named experience, I'm going to create a file named experience2, experience.js. See, I have the folder experience, and inside the file named experience, again. So it's right here. Experience, experience.js. Yes, because it's a bit tight in the sidebar, so I better use that. In that file, we're going to export a class. So default class experience. So now you know the classes. We are creating a class. We are exporting that class. That's what we just learned. And we are naming this one experience. By the way, you can remove the name, but when you get some errors, the name of the class will be shown in the logs. It can get handy also when doing some logs or warnings or whatever. So I recommend you to always name your classes. Then inside of it, we're going to do a constructor like that. And let's do here start a great experience. Why not? Let's go. So I have a class inside that file, and I'm going to use that inside my script. All classes related to the experience will be in that folder. Okay, this way you can have a more complex project with many other classes related to other part of the website that has nothing to do with WebGL or Three.js or the game you're creating or whatever, but everything related to the experience will be in that folder, separated from the rest. Better for maintenance. So from the script.js file, we are going to import the experience from, and you have to put the path right, so it's experience/experience.js, like that. And you can do maybe a log to make sure that you didn't do anything wrong. So that's our class, and we can instantiate the class by doing experience equal new experience, like that. And that's the interesting part if you work with a team. Like let's say you are in charge of the WebGL part. I don't know, there is a part of this specific page that has some WebGL. Well, you will work on this class and this folder, and the other developers will instantiate your class by importing this and instantiating the class. Okay, great. Sometimes, and it will be the case for us, it's useful to be able to access the experience right from the console. Like, see, I have this variable, and I want to access it and do things like, let's say from here, can I write experience? No. Okay, even if it seems that there is no scope on this one, I can't do that. We can save the instance in window. That's a bit weird. I know many developers don't like to do that. You don't have to do that, but I think it gets handy quite often. So let's go. To do that, we are going to go not in this part, because right now we are trying to work only on the experience.js part. And what we are going to do now is global access, and we do window.experience equal the instance. And we save like that. Why? When I did that, now I have access to the experience by doing window.experience. It's a bit weird. Some developers don't like to do that because it's kind of messy, because we are putting stuff inside this window variable, which is already full of trash. Clearly, there is way too much things in that. By the way, you can also access it by doing experience now. I don't have to write window experience. Yes, that's some weird JavaScript stuff. That's why people don't like JavaScript that much. I know it's weird, but you can now write experience or window experience. It's the same thing. Cool, this will get handy later. You don't have to do that, but I like to do that because sometimes from the console, I want to be able to access it and it's useful. Be careful if you have multiple experiences in your website, or at least on the same page, where the last one will override the first one, okay? Because you always do experience equal something, then the last thing will kind of override the previous things. For our experience, we need to send a canvas, okay? Maybe we could have do something like this, canvas equal document.querySelector, and then we select the canvas from the page. But as we said earlier, we want our code to be able to be used by other developers. And those developers maybe want the experience to work on this very specific canvas that is right here. Okay, and not this one and not this one. And they just want to be able to provide which canvas is supposed to be used. So I can get rid of the console log, by the way. Let me reduce this part slightly. To do that, when instantiating the experience, so right here, when we do the instantiation, I'm going to provide the canvas. So in our case, it's the same code as before. We do document, query selector, and we provide the canvas, canvas.webgl. And if the developer that is using your class wants another canvas, he can put something else here. So he has control over that. That's one way of doing it. So we send the canvas right here. In the experience, we can retrieve that. So we can do here. So let me show you there. Canvas. And as you can see, because it's sent as a parameter of the instance right here, we can retrieve it right here. And we can do, I like to do options. Usually I have more options. And I do this canvas equal canvas. I'm saving it in the properties because I know I'm going to use it later in other methods. So I know I have to save this one. And you can log it to make sure that you do have the canvas. You're supposed to have something like that. In the console of Chrome, you get very different logs when it comes to DOM elements. So this is an element from the DOM. Yeah, that's a bit weird. I don't know what they are doing with the console. So anyway, it's working. If you did something wrong, like let's say I wrote Webel and I forgot the G, you get null. Okay, so make sure you're putting the same thing as me. Okay, that's cool. So now we have access to the canvas because we know we need it. And obviously you can set more parameters if you want to personalize the experience from the outside when instantiating your experience. We are going to add some useful classes. There are handy classes that are not necessarily related to WebGL, as you will see soon. And we are going to put those classes in a utils folder. It's still in the experiences folder. So let's go. In the experience folder, I'm going to create utils folder. Let me show you in the Finder. So right now it's like that. And in that utils folder, we are going to create something like 4, maybe 5 classes that are just useful classes, handy classes. The first one being about sizes. So let's go create a new class. So this class will handle the sizes of the experience. And by that, I mean the width, the height, and also the pixel ratio. We are keeping things simple and can be very different, but I like to have a class dedicated to that. It will do a bit more, you will see later. So we are going to update these values when the resize occurs and warn the experience of that resize. What am I talking about? We are creating a class here, so sizes.js. This class will save the width, the height, and the pixel ratio to be used later. Those values will be updated when a resize occurs, and this class will also warn the experience that a resize occurs. Follow me, you will see what I mean by that. So let's create the class. It's the same code as before. So default export default class, and we use the same name. So it's sizes. I like to put a S to it, so sizes. And we use the constructor like that. And inside of that constructor, so I'm not doing anything yet. You can do, something like that, just to make sure that it's working. And in the experience, okay, so inside the experience, that's my experience, that's my sizes class. We are going to do, well, I like to put a comment here. So setup this.sizes equal new, and follow me on that. Let me put, I don't have much room, unfortunately. So I need to put a layout like that instead. Yeah. So this sizes new, and here we put new sizes, but be careful. We didn't import it yet. If you are using VS Code, VS Code is pretty good at finding your classes, your files. So as you can see, I just wrote new sizes, and there is a suggest here. And if I press enter, it's going to import it automatically. Otherwise, I would have to do it myself. So I can instantiate it here and do import sizes from, and I need to put the path relative to the experience, to the current file, so experience.js. So it's inside the utils folder, and then it's sizes.js. And I save, and I get my yup. Okay, make sure you saved everything, because currently we have many files. Okay, great. We're going to do that a lot. Okay, we create a class the purpose of the class is to do that, and we instantiate it, and another class, and another class, and another class, and everything gets separated inside small boxes that it's very easy to maintain. So what are we going to do in that sizes class? So let's get back to it. First, I said we want to handle the width, the height, and the pixel ratio. So we do this.width, we save inside properties because we know we are going to need to access those from the outside. And I'm going to use the window inner width. This part might be different in case your experience is different. Like if your canvas is a, I don't know, very specific part of your page that doesn't take the full viewport, let's say, well, you need to put something else here. Maybe you can use the canvas, but you don't know yet how to access the canvas from this. We will learn that later. And get the size of the canvas. It's up to you. Currently, we are doing full viewport, let's say full viewport experiences. So I'm going to use the window inner width. This.height equal window inner height. And then this pixel ratio, I didn't put device pixel ratio, it's up to you. And I'm going to do the same math thing, which is window min between the window device pixel ratio and ratio and 2. This is from the previous lessons, okay? We are getting the device pixel ratio, but we are limiting it to 2. So that's those bad smartphone with a crazy pixel ratio, which is just marketing. Where we have less pixels to render because those are totally useless. Okay, great. You can log those. By the way, you can also log this. And as you can see, it logs the class and we can see the properties. So the height, the pixel ratio, the width, you probably have different values. That's cool. Then classic things, when a resize occurs, so resize event, we do window add event listener. So we listen to an event which is resize. And we call, sorry, the suggest is huge, and we call this function. Okay, we did that quite a lot. We listen to the resize event and we trigger this function. Then we can add some line breaks and then we can update those values. I'm going to be a bit lazy and just copy and paste it, make sure that the indentation is good. You can do some tests, log this, and as you can see, when I resize the viewport, when it's getting log, and those values are the right values. Great. That's cool. But we are going to go a little further. Here, we assume that the experience always fills the viewport. All right, that's what I told you earlier. If it's not the case, you will have to do things differently. So now, from the experience, so let's get on the experience class a bit. We can access those like this, sizes, width. I'm just doing a quick test. As you can see, I can access the width. So that's great. We are putting everything related to the size, so the sizes, inside the class, and those values are being updated. That's the point of the classes too. It's not just to have instances and things like that. It's also to put things in a box and access them in a more logical way. So if I do pixel ratio, I can access to the pixel ratio. That's cool. Let's get rid of this one. At some point, we will have to update other values like the camera or the renderer when a resize occurs. If you remember, by the way, we still have the code. When there is a resize, so that's my old code. As you can see, we are updating the sizes object. So it's the old version. But we are also updating the camera with these values we calculated, we fetched, and we are also updating the renderer. And we can update many things depending on what we are doing exactly. So what can we do exactly? Are we going to do that, let's say, in the camera part and in the renderer part, and we listen to the event? We could do that, but instead we are going to do things a bit differently. The idea is that our sizes class, when a resize occurs, we are going to warn the other classes that a resize occurred. Okay? To do that, we are going to use the event emitter. So let's go. We want our sizes class, so this class, to trigger an event, to say, hey, something happened. And later, other classes are going to listen to that event. And when that event occurs, they're going to do stuff like updating the camera or updating the renderer or do whatever you want. How can we do that? We're going to use an event emitter class that I wrote, and you can access it from here, this gist. So pause the video, check the links right below, so the corner, left, right, I don't know exactly on what side you are, and it's the event emitter gist. Gist is just somewhere on GitHub where you put some simple code. So I'm going to access it right here. And this is the code we need. This is something I've made years ago. I just updated it sometimes every 2 years. I update it because we can write things differently. I'm not going to explain this whole code. It's not that complicated, but it's also not interesting at all. But I'm going to show you how to use it. So do not copy this. You might have some issues. Copy from the raw version. So click on the raw version once you have opened this page and copy this code. So this one is clean. You can use it. And inside the utils, we're going to add a second class, which is going to be event emitter.js. Okay, it's a new class. We call it event emitter.js. And you simply pass the code there. Okay, so in a way, you are taking my event emitter class. Just like I told you that putting things into classes is useful when you want to reuse them. That's a good example. You just take this class and you can use it already. So that's great. So I can show you the structure right here. I have utils with my sizes and event emitter. The idea behind the event emitter, so it's we are going to experiment. Okay. We are going to go back to the sizes, save the event emitter.js file, and now we are going to extend this event emitter. So first we need to import it. Just like we did with the robot, the flying robot was extending, so inheriting from the robot class. So now our sizes class is going to inherit from the event emitter so that this class can trigger events and other class can listen to events on it. So import event emitter from, and it's inside the same folder because as you can see here, this is the sizes class, it's inside the same folder. So /event emitter.js. You can just save, make sure that you didn't do any mistakes. If nothing is happening, that's great. And now we can extend from it. If I save now, I'm going to have an error. Can you guess? When you inherit from a class and you want to override the constructor, you need to call super. So that the constructor of my class, so the event emitter class, is being called and everything will work. So I call super. There is no parameters to send. That's cool because the event emitter doesn't have any parameters inside the constructor. And now it's working just the same, but our sizes class now has access to those methods like on, off, trigger, and the other one are not interesting. Like resolve name, it's something internal to the class. Okay, that's cool. But how can we use it exactly? The idea is that, go back to the sizes. When a resize occurs, we are going to trigger something. The class is going to kind of yell, something happened. So we are going to do trigger, and we can choose something to say. And we are going to say resize. So it's just like the sizes class is screaming resize. Then, so you save, trigger resize. You can do a resize. Okay, nothing is happening, but currently our sizes class is yelling resize every time a resize occurs. In the experience class, what we are going to do is listen to that yell. We're going to do this.sizes, so that's our sizes instance of the sizes class, and we do on, so we listen to that resize, and when that happens, we are going to trigger a callback function. And as you can see, it's kind of like the add event listener, but with more simple words. And we're going to do, I heard a resize or whatever. And now check that when I resize, I heard a resize. That's cool. So now the class sizes is triggering events and we are listening to those events and we can do whatever we want here. We could have do the classic window add event listener, but with that we have more control over everything. We just have one class that listen to the native event, and then the rest is internal to our code. And that's better, we have more control. So in there, what we are going to do is, oh, by the way, yes, I choose resize, but you can call it whatever you want, okay? If I wanted to call it Toto, and then my sizes can yell Toto, okay. I heard a resize, okay, cool, seem appropriate. Class, okay. Okay, well, that's it. What we are going to do now, we are going to do multiple things in the resize. Currently, we are not doing anything. But later we will need to resize the camera, resize the renderer, and things like that. So what we're going to do is create a new method. So I'm inside the experience.js file, and I'm doing resize. So it's a resize method. And when a resize occurs, I'm doing this dot resize, like that. Okay, I save. Here I can put back some code. Resize occurred, just to make sure that it's working. As you can see, it's working. When a resize occurs, I'm triggering this function. I mean, I'm calling this function and it's working. You might think, why can't I just give this dot resize like that? I provide this method and it's supposed to be working. There's an issue. Let me show you. If I want to get the size, I do this dot sizes, and let's say I want the width. Now I'll try to get it and it's not working. Cannot read properties of undefined. So sizes seems to be on something undefined. Oh, that's weird. Let me see what's this. This is supposed to be the context. This is supposed to be our experience. So let's see. And I have nothing there. That's weird, but that's actually normal. It's how the context works and how the context might be lost. When you have functions being called like this, and it's the same with add event listener and many other examples, you lose the context. Okay? It's like that. It's something from the very old kind of way of using JavaScript. You lose the context by doing that. So we call a function, we use an arrow function, and we call the function again here. Because we use an arrow function here, the context is not lost. And right here, see, I still have access to my experience. So it's working. I don't lose the context. This is still the experience. If I replace that by a function, a traditional function, as you can see, we lose it. Okay? So that's why I'm doing arrow function like here, like this, and then I'm calling this method I have, so that I can still access the context. There are other ways to fix that, like the binding. We can bind the function. I'm not going to show you that because it's already complex enough, and I'm not a big fan of the binding. Okay, great. Let's remove what I have inside the resize. We're going to put stuff here as we go. When we create the camera, we are going to resize it from here. So we have the event emitter in our utils. We have the sizes in our utils. We're going to add another class that I'm calling time. This class will work a bit like the clock from Three.js, but I like to use my version and to have very specific things inside, as you will see. This class will save the current time. So what time is it right now? We are going to use a kind of a timestamp, you will see. The elapsed time, so how long since since the experience started, and the delta time, which is the time between the current frame and the previous frame. Because as you saw in the previous lessons, this is handy. Sometimes we need to know how long it was since the last frame, especially if you want to do animations that are the same regardless of the frequency. I use those three a lot in my experiences, so I know I always need those, so I'm putting those inside the class, separated from the rest, and I can access those whenever I want. By the way, this class will also handle the tick, and this class will trigger an event on each frame, just like we did for the sizes. So that's a good way to see that again in case it wasn't clear enough for you. So let's go. In the utils, we create time.js file. I will show you in the Finder as always. So it's right here. That's the new file. And we're going to do exactly the same. So import, why did I wrote export? Event emitter from, oh, it tried to do it on its own. Calm down, VS Code. What's happening? up like that, event emitter.js, because we know that class is going to trigger some events. Export default class time, so I put a name on it, extends the event emitter. And then we call the constructor, and we know that because it's extending an emitter, we need to call super inside the constructor. And we can do time instantiated, that's hard to write. Okay, great. We created the time class. Pause the video if I went a bit too fast, obviously. You can also slow down the video, by the way. Now we can use that class. So in the experience.js file, we import it. Let's get lazy and duplicate this one. So time, it's the same as the sizes. It's even in the same folder. So time from utils time. And here we're going to do time equal new time, like that. It's exactly what we did for the sizes. That's why I went a bit fast. Okay, cool. It's not important where you listen to the resize. I like to instantiate all the classes I need and then do other stuff. Okay, so we are going to have other classes here and we instantiate everything. And it's cool because with just one glimpse on the code, you know that it's doing all of those. So inside the time class, we are going to do what I told you right before. We are going to do, so I like to put some setup. So start, it's date.now. Date.now is, check that, a timestamp. And if I refresh, check, it's the timestamp. Those are the seconds since the 1st of January, 1970, something like that. Unix creation or whatever. So as you can see, it's just the time that passes. And it's in milliseconds. Okay, so we save this one. We save the current by using the same one. You will see that this one will get handy right after because we are going to change the current on each frame, but this one will stay the same. This one will store when it started, like the timestamp when the experience started. This one will be the current timestamp with time. So in the next frame, it's going to be a bit more, a bit more, a bit more, a bit more. Then we need to know the elapsed time. So from the elapsed time equals 0. By default, it starts at 0. And after 3 seconds, I will have something like 3 thousandths here because 3 seconds. And then the delta, and I like to put the delta to something. I don't like to put 0. This can create some bugs. I had very specific bugs because I used it, maybe wrong, I don't know, but I put 0 and on the first frame something went wrong and it was messing with the rest. Why 16? Well, because the default screens are running at 60 FPS. And at 60 FPS, the delta time, so between each frame, it's usually around 16 milliseconds, 16 and something. So I like to put a logical value like that. We'll do some tests about those and you will see. Okay, great. Now we are going to create a tick method. We're going to separate that. It's kind of the tick that we used to do, but only inside the time.js class function. And what we are going to do is call this one. So we can do log tick, just to make sure that it's working. And then we use the classic request animation frame to call it on the next frame. So this dot tick. And as you can see, I didn't provide this tick for the same reason as before, because we're going to lose the context. This will be lost on the next frame. I mean, when this will be called, this will be lost. So we need to provide an arrow function. In the arrow function, we have access to this, and this we call tick, and we will keep the context. That's weird. You can just remember we keep the context by doing that. Okay, great. And we need to call it at the beginning. Do we have something? No. So we could do that tick, and as you can see, it's going to work. Tick, 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 tick. So I have around 60 per second if everything is working fine. But what I like to do is window request animation frame. So it's kind of a lot, but you will see that it's kind of important too. This dot tick, just like we did here. I'm not calling the tick function immediately. I wait one frame. I will show you why a bit later. Yeah, actually, it's going to be, yeah, there. So now we can do some calculations. So first, we want the current time. So we do const current time. So this is what we already did in the previous lesson, but let's repeat that. It doesn't hurt. So we do date.now. I want, when this tick function is being called, so on each frame, I want to know the current timestamp. So we can test it, check that, current, as you can see, I get a lot of those. Let's remove it before my computer burns. Then, now that we have the current time, we're going to calculate the delta time. So between now and the previous frame. That's why I didn't put this one in these properties already, because I need to compare them. I need to subtract them first. So this is the delta, and it's the current time, and we subtract the previous time. And check that. We get that. So 4, and then it gets up, up, up. That's weird. It's because the current time is not being updated. So this .current is not being updated. So we need to update it now. We compared to the previous one. Now we update the current time to be used on the next frame. So this current equal current time. And if now I log it, check that, delta time, we get something like that. And that's why I told you earlier, it's around 16. Okay, because my screen is running at 60 FPS, so the calculation gives us something like 16. And that's the part why I like to wait a frame. If you call the tick from the beginning, like if you do something like that, on the first frame, the delta will be 0. Because you will compare what the date now to the actual date now. So something minus the same thing, in which you subtract the same thing, you will get 0. And the delta will be 0 for one frame, just the first frame, which is usually harmless. But in one project I had many issues because of that, and I lost hours trying to figure out what was the issue, and it was because the delta was 0 sometimes. So it was a bit weird. So that's why I like to wait one tick before doing that. And finally, we can calculate the elapsed time by doing elapsed equal this current minus this dot start. So classic calculation, I can just show you it's how long has been spent since we opened the page. I mean, since the experience started. So it's been 5 seconds, 6, 7, 8, and we can use that value to whatever we want. Okay, that's great. We have all those values calculated in a separated class. I already like that. Things are separated, put in boxes. That's cool. What we are going to do now is just like we did for the sizes, we're going to trigger an event. So trigger tick. I like to call this tick because why not? It's a tick. And then we listen to the tick. It's kind of funny. So we trigger tick. Because it extends event emitter, we have access to the trigger. And now in the experience class, so we get back to this one, we can listen to that. So we do the same thing. Time on tick. We should put that a command too. Let's put comments. Sizes, resize event. Time tick event. And we trigger, so we call that function when the event occurs. And we are going to do the same as for the resize. We're going to call, and it's going to be update. And we can create that method because we are already separating stuff because we know we're going to put things inside of those. So when a tick occurs, we call our update on the experience. So we kind of update the experience. That's cool. Here you can do final test. Update the experience. Update the experience, update the experience. But everything about the time is located in the time class. Separated. We separate everything. And here we are going to update the world, update the Fox animation, do the renders and everything. And update the orbit controls class, etc. By the way, we use the event emitter twice. The event emitter can be used for any of your classes that need to trigger events, okay? It can be when an animation of the model has finished. It can be that an object has been clicked on. It can be because you created a game and the player just finished one level, so you trigger an event, and then when this event occurs where you destroy the previous level and create the next level. It can be because an enemy died and then you play a sound and you increase the score or whatever. please use that event emitter class so that your classes are triggering events. We are going to use it again, actually. Later, we're going to use it to tell the experience that all the resources are loaded. Okay, we're going to use it one more time when we are going to handle resources. Okay, that's cool. We are going well. We can start doing some Three.js finally, and we can create the scene. So in the experience class, this time we are not going to create a class. You don't need to create a class for everything. We want to create the Three.js scene, and we're going to put stuff inside of that. I like to do that in the experience. So to do that, let's do it after the time. We can do this.scene equal new 3.scene. Be careful, you need to import Three.js. So Three.js, I like to do libraries imports, dependencies imports from node modules, sorry, imports from the beginning. So import all as 3 from 3. Don't forget to import Three.js. And we instantiate the class. And that's all. That's all. Sometimes you don't need to create a class and a file for just one line of code. I'm just creating the scene like that. For the camera, well, the camera is different because we have more stuff about the camera. We need to do some resize stuff. We need to create the instance, and we are also going to create the orbit control inside of the class, the camera class. So for this one, we need a specific class. So it's not going to be in the utils, it's specific to the experience. So inside the experience folder, so this experience folder, on the side of the experience.js file, you're going to create the camera.js class. And inside, as you can see here, and inside of this one, export default class camera, like that. And we do constructor, and we do my camera. Why not? Then inside the experience, so it's the same. We export default class. We don't have events. We don't need to use the event emitter or whatever. Inside the experience, we import the camera. So camera, it's not in the utils folder. It's on the same folder. So ./camera.js. And we instantiate it after the scene. And we do this camera equal new camera, like that. We save, and it seems to be working. I have my camera here. Okay, great. Let's continue. We have an issue. The following code for the camera, well, we need to create the camera, and we need to create the orbit controls, and we need to do some things on the resize. Let's check back in our script.js file. The camera is over there. As you can see, to create the camera, let's uncomment this part. You don't have to do it, I can show it to you. We need to provide the field of view. We need to provide the size width, size height. Those, we have those inside the sizes class, but we don't have access to the sizes class inside the camera class. Another things for the orbit controls, when you instantiate the orbit controls, you need to provide the camera. Okay, that's not an issue, but you also need to provide the canvas because of the events that will be listened on the canvas when you drag and drop on the canvas. So when you create the orbit controls, which we are going to do right now, we need to have access to the canvas. In other words, inside of the camera, we need to have access to the experience, to this class. Okay, so inside the camera, we need to have access to the experience in order to access the canvas, the sizes width, the sizes height, or whatever. How can we do that? There are 3 ways. There are actually more ways, but there are 3 main ways of doing that. From a global variable, we already know that actually, by sending a parameter and by using a singleton. And we are going to learn to test all 3 of them, but only use one. Okay, for the sake of learning, I'm going to show you all 3 of them because I think all 3 are viable solutions, but we are going to use only one. So let's go. The first one was accessing the experience. The first one was from a global variable, and we already do that. Remember the window.experience? Well, that's great. That means that inside the camera, we can do this.experience equal window experience. and I can log it. And as you can see, I have access to the experience. So I can do experience.sizes dot width like that. And I have access to the width. That was very simple. But thing is, I already told you that many developers doesn't like to have those global variables that are just here, which is weird because any other developers can add some code that will mess up with that and that will mess up with our camera class. So it's a bit messy. That's the reason we are not going to use that. Though I really like this solution because it's the simplest solution. So second solution from a parameter. What do I mean by that? Here, from the experience.js file, we're going to send to the camera the experience itself. So we're going to do this. We send the experience itself to the children, so to the component, to the camera. In the camera, we can retrieve it here by doing experience. So it's a parameter that we send. And here we can do that. That's all. And it's working. As you can see, I have access to this experience, sizes, width. That's great. This one is working really nicely. I really like this one too. The only issue is that you have to put a lot of parameters and to save them. So you need to send it, get it, send it, get it, especially when you have a lot of depth, like classes, inside classes, and suddenly this one at the very depth of your structure need the experience. You need to go back and send it from the top to the bottom. That's the only problem with that solution, though I really like this solution. And we are going to see a third solution, which is by using a singleton. That's actually the most complex solution, but it's actually a clean solution. A singleton is a class that will instantiate just like usual when it's the first time. So you instantiate your class, well, you get an instance, that's great. But for all following times, so if you instantiate again, it will not create a new one. It will return the already created one. So let's say you create a house from a class, you will get a house. And if you do that multiple times, you will not have new houses. You will still have the same house. That's all. That's the idea. You can't instantiate it multiple times. You can do it, but you will always get the first one. That's the idea. So let's go. Let me show you. We'll understand once you see the code. First, we need to convert the experience to a singleton. Here's one way of doing it. There are many ways, more complex way, but I think it's already way too complex, so I want to keep things simple. I'm going to create an instance variable here. It's going to be the instance of the experience, and by default, the experience has not been instantiated. But here, when the experience is being constructed for the first time, we are going to do instance equal this. Okay, so the first time you instantiate the experience, we save it inside the instance. But before doing that, we are going to test, does it exist already? Is there already something in that instance? If so, we return that instance. So the constructor is not going to do the rest. The constructor is going to return what has already been instanced. So to recapitulate, the first time we do new experience, everything will just go as planned, but we are going to save it inside the instance variable. If we do new experience again, this time it will go inside that if statement and return the already instantiated experience. Now, to use that, you go, let's say, inside the camera. In the camera, we want access to the experience. We are not going to, let's get rid of the previous solution. So I'm going to get rid of this here. I'm going to get rid of this one, and let's comment this one for now. Okay, so I remove the this from here. I remove the parameter from here, and I commented this part. Here, what I'm going to do is import the experience. That's weird, but trust me, it's going to work. Import experience from, and it's from the same folder, experience.js. So I'm importing the experience. Sounds weird, but now what I will do here is new experience. I don't need to send anything. And by doing so, I get access to the first experience. Because the first time it didn't went inside that if, but the second time it returned the already created instance. I can show you like A, B, A, B. So the first time it just went to the A, and the second time inside the camera it just went to the B. Okay, so we're going to use this one. I do like this one, but I think it's a bit complicated. If you don't like it, don't use it, okay? It's a bit complicated, so it's up to you. The other two solutions we saw are just fine. It's up to you. Okay, so from the camera, what I like to do is save the experience inside the property. Why not? It can get handy at some point. I like to put things in box. I like to put things in properties. Now we can retrieve things that we need from the experience. So the first thing we need is sizes. We already know what we need, but obviously while you code, you will add those properties as you need them. And we do this.experience.sizes, and then we do this.experience.scene because we need to add the camera to the scene. And then we do this.experience.canvas because the orbit control that we are going to create inside that class need the canvas. And you can test that everything went well by logging this. And as you can see now in the camera, we have the experience, the canvas, the scene, and the sizes classes, instance. And that's great. Okay. We are going to create the camera itself, so the perspective camera and the orbit control. So let's go. We're going to separate into methods just to have things in boxes. So I'm going to do set instance. I'm creating a method and I'm calling this method from the constructor set instance, like that. And in here, I'm going to create the actual camera, so the Three.js camera. So this.instance equal new. I need Three.js, so I do import all as 3 from 3, like that. And in here, I will do 3. If you remember, you can check your script.js file. It's perspective camera. It's going to be 35 degrees of field of view. And now we need the width and the height, and we can do this. I'm going to add some line breaks so that you guys can see without me scrolling. So it's going to be this.sizes.width, so that's the width. This.sizes.height. And do I have something else? Yes, we have the near 0.1 and the far 100. Okay, that's great. So we created the instance. Now we can move the camera backward a bit. So instance position set. Actually, it's not backward. It's kind of on the side. Diagonal. 6, 4, 8. I'm just getting those values from the script.js file, the initial code. And then we add that to the scene. It's not mandatory, but you better do that. You might have some bugs, especially with raycasting, if your camera is not inside the scene, or that you rotate the scene for any reason. So add the camera to the scene. Great. No error. Make sure you are calling the instance. If you get some errors, pause the video, check the error, fix the errors. Cool. Now we can create the orbit control. We're going to do the same, put things in boxes, set orbit controls, like that. And we create a new method like that too. So don't forget to call it right here. And here we are going to do quite an easy one. This dot controls equal new orbit controls. Be careful, we need to import this one. So I'm going to be a bit lazy and get it from my script.js file. And this is how we import the orbit controls. Okay. Where is it? Camera, right here. So we import the orbit controls like that. And we use it like that. And for the orbit control, we need to provide the camera. So it's not camera, it's this.instance. That's why we created the orbit controls after the perspective camera. And the second parameter is the canvas itself. So this.canvas. And we're going to enable the damping. It's when you move, it's kind of smooth. So it's a bit better. And that's actually interesting for what we are going to do next. Enable damping equal true. I hope I got it right. Enable without the D at the end of enable. No error. That's great. If you do an error, you will get an error. Okay. So make sure you don't have any error and that you're calling the set orbit controls. We are separating inside method just to have everything clear. If you prefer to have everything in the constructor, you can have that. I like to have things separated so that if I don't want the orbit controls, I just do that. The method won't be called, but it's still available if I need. Great, let's handle the resize. So it's a bit complicated because we can't see it yet because we have nothing on the screen, but we know that we need to be able to resize the camera. You remember from the aspect, and then we need to do update matrix or whatever. So we could already we could do something like this, sizes on resize. Because remember, this is my sizes instance of the sizes class. And we could do something like that and do hey. And here we could, as you can see, it's working. We could update the camera. That would be cool. And actually, that's how I like to do it. But we are going to do things a bit differently to avoid some potential bugs. The idea is that we already listened to the resize on the experience right here. And when the resize occurs, we call this one. This will propagate to the children, to the components inside of the experience. And those will propagate, if needed, to the children and children and children through the whole experience, through your whole structure. That's a bit better than having each class listening to the resize because you have more control over the order of what is being resized. And I got some bugs where each class was listening to the resize event on its own, and some class were doing the resize before the other one, and it was bad because I was listening to it before, so it was called before, and there was some bugs because of that. So I prefer to listen to the resize once from the experience and to propagate to the children. So we're going to do that with the camera. So this camera, and we call resize, which doesn't exist yet. So this camera resize. And inside the camera class, so from the experience, we call this camera resize. And inside the camera class, we create that resize method. Resize on the camera or whatever. Now we can resize and it seems to be working. And inside of this, we are going to update the instance, so the perspective camera instance. It's the same code as before, so instance aspect. We need to update the aspect. Check the previous lessons if you don't know what I'm talking about. So it's going to be this.sizes.width divided by this.sizes.height. And when you do that, you also need to update the projection matrix. So this instance update projection matrix, like that. Do a resize. I know we can't see anything, but if you did a mistake, you will have an error here. And fix the error, obviously. All right, it's going well. We're starting to have some clean structure, but still we can't see anything on the screen. So we already did that actually. And we can call the update. Yes, indeed. By the way, again, we need to do some code without checking anything because we have the enable damping. If you remember from the lesson where we added the orbit control for the first time, enable damping will make the animation kind of smoother when you drag and drop. That's great, but we need to update the controls on each frame. So we are going to do exactly what we did with the resize, but this time with the update. And you will see that it's getting kind of the usual thing and it's logical. So from the update, we call this camera update, like that. This method doesn't exist yet. So we move to the camera and we create a update function. And in that update function, we do this. Let me check. I think it's orbit control. So this controls update. This is how the orbit controls need to be updated on each frame. And that's all. And as you can see, we propagate from the experience, so the top class, to the children. And you will see that we will have children inside children when we have the world, the fox, the environment map, etc. Okay, great. Can we see something on the screen at some point? Yes, here we are. We're going to handle the renderer, and shortly after, we are going to be able to see something on the screen. So let's do kind of what we did for the camera. We are going to create a class that will handle renderer. So new class, renderer.js. I'm not going to create the WebGL renderer inside the experience because I know I have quite a lot of code in it. Okay, so that's usually the reason why I create a class. I have, I don't know, more than 4 or 5 lines of code. I create a class, and at the end I usually have way more lines of code, so it's usually a good idea. I mean, so this renderer class will not have events to trigger, so we can do. Let me check. Export default class renderer. We can use the constructor. I mean, we can add a constructor like that. Oops. And we already know that we need to access to the experience because we need access to the canvas, to the sizes, to the scene, to the camera, and things like that. So we are going to do the same as for the camera. We are going to import the experience and use the fact that it's a singleton to instantiate it. That will fetch us the base instance of the class. So this.experience equal new experience. We get the initial instance of the experience class. Okay, great. We can do a quick test. All good. Okay, just to make sure that it's working before adding too much code, we go to the experience. We import the renderer. We instantiate the renderer. So for now, it has nothing to do with Three.js yet. So we do, renderer. Okay, and it seems to be all good. Great, make sure you are saving everything, so the renderer and the experience.js file. So back to our renderer.js. I already know what we are going to use. So we need the canvas. You would have add those as you need them, but right now I know where this is going. So canvas, sizes, scene, and camera. Okay, because when you do a render, you need the scene and the camera. When you resize the renderer, you need to provide the size and also the pixel ratio, and you are going to draw inside the canvas. So when you create the WebGL renderer, the Three.js WebGL renderer, you need the canvas. Okay, I already know that. So that's cool. And we're going to do the same thing. Let me check. Yeah, that's it. We're going to create the instance of the renderer. So it's going to be the WebGL renderer, which you can check right here, the classic WebGL renderer. So let's go. This, I'm going to put it inside the method. So set instance. And I'm going to do this.instance equal new 3 WebGL renderer. And I forgot something. What did I forget? What did I forget? Yeah. To import Three.js. Import all as 3. Don't worry. I always forget this one. From 3. So we create the instance. You can do a quick test just to make sure that it's working. Oh, by the way, we need to provide some properties when instantiating the 3 WebGL renderer. So we need to provide the canvas. So canvas, it's an object. This.canvas, and we are going to set the anti-alias because it looks better. Anti-alias true, and we can just do a log of that, and we test, and everything seems to be working, and we have something on the screen. That's cool. The canvas is too small, but don't worry, we are going to fix that soon. And we can do what we already had in a script.js file, which is the physical correct light, the output encoding, the tone mapping, the shadow map, the resize and pixel ratio stuff. So let's go, let's get lazy. Let's go on the script.js file. I'm not going to write all of those because it's too long. I'm going to take those from here. So go on your script.js file, the renderer part, go there and put those here. And you need to replace renderer by this.instance, okay? Because this is how we created the class. So let me see, everything seems fine. Oh, we are going to have an issue. If I save, it's not working because we are resizing it by using the sizes width and sizes height. Those are not available. We need to use our sizes class. So we need to do this.sizes.width, this.sizes.height. And for the pixel ratio, we don't need to do this calculation because we already did that in the sizes class. So we do this.sizes.pixel ratio, and everything is inside their boxes. And now it's better. Our canvas is taking the whole screen because in the sizes class, we asked for it to the width and the height to take the whole viewport. That's great. We have almost something on screen. Now we need to handle the resize. We know that when we are going to resize it, well, we need the canvas, the renderer, to resize on both axes, so on the width and on the height. I'm going to put that back here. Yeah, right here. We can create the resize class just like we did for the camera, and we are going to do the classic thing, which is I can be lazy and take it again, or actually we can take it from the code we already wrote there. So that's the code we need. So we set size and set pixel ratio like that. And from the experience, we're going to propagate the resize to the children. So we did it for the camera. Now we can do it for the renderer. So our renderer class. I save, and as you can see, when I resize, it takes the whole viewport. Things are being updated just like we want it. Let's go forward. We can do the same thing for the update, because when we update the experience on each frame, well, we want to do one render. So let's go update, and we do this instance render, and we're going to use the this.scene. That's our scene that we created in the experience class, and the camera is this.camera. But I did a mistake. It's not the camera class, because this camera is our class. The actual 3GS class is inside the instance property of our camera class. Okay, the perspective camera is inside the instance property. So it's this camera instance, like that. Yet again, we need to call this function from the experience. So we do this renderer update, and we have control over the order. First, we move the camera, and then we do the render. If we do the opposite, it's not a big deal, but still it's not accurate, and we will have an offset in the real position of the camera and what we see on screen. And it can create some minor bugs and sometimes bigger bugs, so we need to make sure of the order. That's why we are doing this way of structuring for the resize and the update. Great. We have almost something visible. So it's long, I know, but it's how I do, and in the end you will have everything inside boxes well organized. So yeah, it's time to add something visible to our scene. We're going to separate everything that compose our world in a class and a folder named world. Okay, we have the camera, the renderer, the experience, we have some utils classes. Okay, but now we are going to have the actual world that we will be able to see in the renders, and we are going to put that in a separated folder. This part actually depends on what you have in your project, but currently that kind of matches what we can do. So we are going to create a new folder named world inside the experience. So I can show it to you again like that. And inside this folder, we can create the world.js class. Okay, the experience, the world folder, and the world.js file. And here we are going to do the classic thing, which is export default class world constructor, because we need to do stuff when the class is being instantiated. We need to have access to the experience. So this.experience equal new experience. We need to import that experience. Be careful, the experience is one folder above because we are writing code inside of this. We want to access this class, so we need to go up from one folder. So we do import experience from, and it's // This is the way of going up of one folder, experience.js. Okay, great. The world, something like that. We don't really care. The world, yeah, okay. Then here we can instantiate it. So no surprise, we can do import world from, be careful, it's inside the folder. So it's going to be /world/world. It's a bit redundant, but I think it's clean like that. No surprise with the names, and everything is still inside folders. So here we can instantiate it. after the renderer. So we do world equal new world, like that. And it seems to be working. In the world, by the way, we also need to have access to the scene because we are going to add like an object to the scene. So we do this.scene equal this.experience.scene. Do we have access to the scene? Let's make sure of that. Yes, it's working. We have access to the scene. Great. Let's add finally something visible on the screen. We're not going to put the fox and the floor already. We're going to just create, I don't know, a cube and see that cube. So test mesh const test mesh equal new 3.mesh. No surprise. Oh, by the way, we need to import Three.js. I almost forgot. So import all as 3 from 3, like that. So we create, we need the geometry. So box geometry 1, 1, 1, new 3 mesh basic material, just to make sure that we can see something. Wireframe true. Why not? Let's put a wireframe and we add it to the scene. So scene add test mesh. Do we have something? Oh, I made a mistake. Import all as 3 from 3. New 3 mesh basic. Oh, material with a upper M like that. And we have something finally. And as you can see, things are being rendered. The orbit control is working and still everything is inside boxes, inside classes, inside separated files. So it's working nice. And we have our experience working. Can we resize? Let's make sure that everything is working. Yes. And things are being updated. If you don't have this result, obviously pause the video, check what's wrong. And if you have issues, come on the Discord, members only Discord server, and we will help you. Because it was quite a lot of code without seeing anything on screen. Okay. Don't forget that we need a floor, a fox, an environment map, the sun, the shadow, and a debug UI. So we still have some work to do, but right now we are going into the real thing because we can see some stuff. So let's add some light. We need to add light to the scene that we are building. This is part where the structure can vary a lot, okay? This really depends on your projects, how much you have to create, how much you want to separate things, how many developers are working and on which part, so you can really adapt to the project. We're going to create an environment class. This environment class will handle the light and the environment map texture. Okay, let's change the material to mesh standard material so that we can see if the light is working. So right now we are getting almost full black. Maybe you can see something there. It's because it's not reacting to the light because we have no light. Okay, the mesh standard material needs light. Remove the wireframe too so that we can see the shade once we have the light working. As I said earlier, we need to create the environment for the light. So we are going to create a new file. So it's going to be inside the world because it's part of what we can see. And we do environment.js like that. And in that, we are going to do export default class environment. Inside of that, we need to access the experience. So we do the same. Import experience from /experience because it's the folder right above and environment experience. Here we can create the constructor. You can copy and paste if you want. And we do this experience equal new experience. Okay, and we need the scene too. This.scene equal this.experience.scene. Oops, like that. Let's make sure that we have access to the scene. And now in the world, so not in the experience because we are creating stuff in the world class, we're going to import that class. So import environment from the environment.js file. And here we are going to instantiate it. Let me check. Yes, at the end. So do it after the test mesh. So setup. Again, we're going to create a bunch of classes. The code inside the world class will be very simple, you will see. Environment equal new environment. And we get the scene. Make sure you saved everything. So put it after the test mesh, it will get handy later. Inside that environment class, we are going to remove the console log and we are going to create two things. So the light and the environment map. So let's start with the light and I'm going to put it inside a separated method. So set sunlight like this. And we are going to create it like that. And we are going to instantiate it. Yet again, let's get lazy and get it from light, directional light. Okay, I call this directional light here, but we can take it anyway. So from your initial code, we can put it there. And we're going to change some stuff. Oops. We're going to save it inside a property because I like to put things in box. So it's going to be sunlight. It kind of differs a bit from the initial code. Equal new directional light. And we need to change those to this sunlight. And it's not going to be scene because we don't have just a scene variable, but it's going to be this dot scene. We save. We have an error because, again, I forgot to import Three.js. Import all as 3 from 3. And now we have our light working, as you can see. So, next part. Next part is actually a bit more tricky because we need textures. So it's not just JavaScript code, we need to add textures, so we need to load textures. We could, I don't know, like create the cube texture loader like we did earlier because we are going to load, like in the script.js file, those textures, so those environment map. We can create the cube texture loader inside that environment map. But if we do that for every classes that need to load something, it will get a bit messy and each class will add the things once they are loaded. You will have less control over everything. Things will pop on the scene when they are ready. Sometimes this one will be loaded faster than this one. I mean, it's a bit messy. So we're going to do things a bit better. We're going to centralize everything in one class. This class is going to be named resources. And that's also a good way of handling the loading because you know when things are being loaded and you have the progress among the different assets to load. So we are going to instantiate all the loaders we need from that class. We are going to loop through an array of assets and load them. So we will provide the different assets to load. We will loop through those assets and use the right loader for each asset. And when everything is loaded, so all the assets are loaded, we're going to trigger an event and our experience class is going to listen. Actually, it's not going to be the experience, it's going to be the world class. It's going to listen to that event to start creating the world. And we will use that for the environment map, but also for the Fox and also for the floor textures, etc. So let's go. We're going to put this one inside the utils class. So in the utils class, let me show you again from the Finder. So it's going to be there, utils. So we do resources.js. Inside of it, it's the same code. So we can already import event emitter from, we don't need the experience. We need the event emitter. So event emitter.js, it's inside the same folder. Then we can export a class. So export default class, which is going to be named resources, and that class extends the event emitter because this class is going to trigger an event at some point. And we can already create the constructor and call super because we are extending something. We need to call super so that it works. Okay, great. We can now instantiate it from the experience class. And we can do that right after the scene because we're going to need it in the world. We're not going to need it in the camera and the renderer, but in different projects that might happen. So we need to do it a bit earlier. So resources equal new. Resources, I didn't import it yet, but if I press enter, VS Code, so don't forget the parentheses, VS Code will import it. And we'll do it the same way as you have imported the previous classes in terms of syntax. That's just a cool feature about VS Code. As I said earlier, for the list of assets to load, we are going to use an array. In that array, we're going to provide objects, one object for each asset to load. And for each of those assets, we're going to have three properties. Do not worry, it will make sense once we write it. The first property is going to be the name of the asset. We are going to choose one name for the asset. It's the name we are going to refer to later in the classes. We're going to also provide a type so that we know which loader we should use. And we are going to provide the path or path because it can be multiple paths. Like for the environment map, we have multiple textures to load. Okay, because it's quite a heavy array, it's good practice to put it in a different file. Okay, just because it's a bit too big. So what we're going to do is inside the experience folder, we're going to use the modules, but this time not to export a class, we're going to export an array. So let's go. We're going to call this one sources.js, and we are going to tell this file to export default, and it's going to be an array. Be careful, I think you can't do that. Maybe it's going to break something. So let's put it at the end of the line. And here, as I said earlier, we are going to provide an object for each asset to load. To begin with, we have only one asset, which is the environment map. But this one is composed of multiple files. So it's going to look something like that. An object. We choose a name. So it's going to be environment. I'm going to have trouble writing this one without doing a mistake. Environment map texture. Type, we choose something that we will refer to later, so cube texture. So when it's a cube texture, we are going to use the cube loader or something, cube texture loader, I think it is. And then we provide the path, so singular, because for the other one, it's going to be only one. And we provide the different textures to load. So if you remember from what I shown you earlier, it looks something like that. Okay, those are the files we need to load. So we do textures, environment map, px.jpeg, and we provide 6 of them. So 6 is something like that. So px, nx, py, ny, pz, and nz. Okay, you can find those in the script.js file. Okay, great. We save this one. Then, in the experience class, we are going to import that. It's not a class, okay? By the way, I didn't put in camel case because it's not a class. I put s in lowercase. So let's get back to the experience, and we're going to import it. So we do import sources from sources.js. You can log it to make sure that you didn't do any mistake. And as you can see, we have an array with inside one object. Currently, we will have more later with the name we chose, path to load, and the type, which is cube texture. Okay, that's great. Let's remove the console log, and we are going to send that to the resources class right here. So we send the sources to load. In the resources class, where is? I don't have much room. There, first we need to retrieve the parameter, so sources. Let's make sure again that we get it. Super needs to be at the top of the constructor. Yes, we do have access to the sources. What I like to do is save options in properties, so I do options. We did that for the canvas, now we can do it for sources of the resources, and we do sources, like that. Again, if you want to test, make sure that you didn't do any mistake, you can do that. Okay, that's cool. And we can move on. So let's get rid of the console log. In the resources class, we're going to have 3 properties. The items, which are the loaded resources. So once a source is loaded, we are going to end up with kind of a resource, and we will be able to access it in the item object. To load is going to be the number of sources to load, and loaded is going to be the number of sources loaded, so that we can compare them. If if loaded equal to load, well, that means we loaded everything. So setup, I think it's the next slide. Yes, it is. This dot items, by default, we have nothing. Okay. Once an asset is loaded, we are going to add it to that object, but only once it's loaded. This dot to load, so that's how many assets sources we have to load. So it's going to be this sources dot length. This class can be greatly improved, but I try to keep things quite simple. And loaded by default is 0. When an asset is loaded, well, we increment this one and we add the resource element to the items. Okay, great. Now we need some loaders, and we already know the loaders we are going to use a bit later. Obviously, you would have add the loaders as you need them. Don't add every possible loaders that you can have. There are thousands of loaders if you go beyond what Three.js provide. So just add the loaders you need. This.set loaders, and we know that we are going to use in that project the GLTF loader, the texture loader, and the cube texture loaders. So we are going to put it in a separated method right here, and we are going to save them in one box, which is the loaders. I like to put everything in properties. This loader, so the GLTF loader equal new GLTF loader. Be careful, I didn't import this one yet. Then we have the texture loader, new, this one is, I don't have to import it, but I need it from the 3 class, so we are going to need this one too. So don't save, this one is not going to work yet because we didn't import anything. And the cube texture loader, I think it's inside the 3 class, yes it is. So 3 cube texture loader. All right, so we need to import the GLTF loader and the 3 class. For the GLTF loader, let's get lazy as always. It's right here, okay, from the script.js file. That's why we are commenting this one to retrieve some code when we need. So we can import it. I like to do like this. So import all as 3 from 3. And then the GLTF loader like that. We save. I did a mistake. Texture loader. Let me check. 3 GLTF. Okay, this one seems fine. Oh, I forgot the T, uppercase T right here. So it's Pascal case. That's on me. Okay, great. So we have the loaders ready to load some assets. Then, oh, by the way, we are not using a Draco compressed model, but if your model that you are trying to load uses Draco, well, you need to implement Draco. So the Draco loader, add it to the GLTF loader, check the corresponding lesson. We already did that. That's just a quick warning. What we are going to do now is create a new class, a new method. So it's going to be start loading. Sorry, loading, not loader, like that. And we are going to call this one already, this start loading. Again, it's 2 separate things. Start loading, start loading. Okay, great. In that start loading class, we are going to loop through all our sources that we are supposed to load. Okay, we have only one, but later we will have more. So load each source for cons source of these sources. So we are looping through the sources. You can do a quick test. As you can see, I have only one, but I'm looping through the array. The array we imported from the source.js file, imported in experiences.js and send it right here. Okay, small reminder. And now what we are going to do is test the type. Let me show you again the sources right here. We have different types. Currently, we have only the cube texture, so we know that we need to use the cube texture loader if it's cube texture. And we're going to do different stuff for the other loaders. So let's go. It's going to be in the resources. If source.type, we could have used a switch, but let's keep things simple. Equal, it's the same as equal, so use whatever you want. In our case, it's the same. So if it's a GLTF model, because we're going to add one that we have the type GLTF model, well, we do this loader. So I'm going to use the GLTF loader. And we're going to load. What are we going to load? Well, it's going to be the path of the source. So it's going to be source.path. And when it's done, we're going to call this function. And we provide a file. We get a file, and we are going to log it first. All right, let's keep things a bit simple for now. We're going to log the source and the file. So this is the source from our array of sources to load. And this is the final file we get once it's loaded by the corresponding loader. So right now, all we have is the GLTF loader here. We need to continue. We need to do the textures. So else if, and I'm going to be lazy, check that, I'm going to copy that right here. Okay, I took the if with the curly brackets and I put it there. So if this time it's a texture, so the type is texture, I'm going not to use the GLTF loader, I'm going to use the texture loader. Okay, that's this one, the texture loader. We create only one loader per type. And we use the source path again, and we do a classic console log. All right, cool. No issues there, because all Three.js loaders kind of work the same. You load it, you provide the path, and then you have a callback function once the thing is loaded. And we can do the same again. So I'm copying this part, I'm duplicating this part, and this time it's for the one we need actually, which is a cube texture. Okay, that's the type we want right here, the cube texture. We already prepared for the rest of the lesson, but right now we need a cube texture. And we're going to use the cube texture loader to load the path, because we need to provide an array of 6 images. And at the end, when it's loaded, well, we just do a console log. All right, finger crossed, check your code. That was quite a lot. If everything went well, as you can see, we're logging the source. So this is the initial source, and this is the loaded file. So as you can see, this is the source. It's the same as before. We have the name, path of things to load, and the type, which is cube texture. And once it's loaded, so maybe it can take, I don't know, 1 second, 2 seconds, or whatever. We are in local, so it's quite fast. We get the cube texture, which is a Three.js class. And if we had loaded a simple texture, we would have get a Three.js texture. And if we had loaded a GLTF model, we would have get the, I think it's a group or whatever. We will see that later for the Fox. That's great. Pause the video if you don't have the same result. What we are going to do now, instead of logging the result, we need to save them inside the items. So those are once the items are loaded, and we need to update this variable. So for each one that we load, we increment this one. And if at the end we do a test, if the loaded value is the same as the to load value, well, that means we finished loaded everything and we can start the experience or whatever you want to do. Okay, great. So what we're going to do is add a new method. Be careful, we have quite a lot of curly brackets. It's going to be source loaded, and we're going to call this one every time something is being loaded. For this one, we need to provide the initial source and the loaded file. Okay, those are the parameters we need. And here, instead of doing console logs, well, actually we need to do, so I can replace all three at once, this dot source loaded. Okay, the first one, once the GLTF model is loaded, we call this source loaded and we provide the source and the file. Same thing for the texture, same thing for the cube texture. Okay, great. In here, currently, we are not doing anything. First, we need to save that resources, that loaded file. So we do items. We save at the source.name. Small reminder, the source.name is this one. So it's the name that we choose. When we create the source to load, we decide that the name is going to be Toto or whatever. So I decided to use environment map texture so that I can refer to it later. Equal what we have loaded, like that. Then we update the loaded value, because we just loaded one asset, so we say loaded plus plus, so it's going to be 0, 1, 2, 3. And finally we test if this loaded equal this to load, meaning that we finished loading assets. And when this happens, we trigger the event that the resources are ready. Like that. We could have provided something else like loaded, everything loaded, or whatever. Loaded is just fine. So we trigger an event loaded. Does that happen at some point? Finished. Like that. Yes. Because we have only one asset to load. Be careful, if you provide wrong path, well, the callback will never be called, and you will never have loaded being updated, and the ready will never be called. So I'm not going to put loaded, actually, I said we're going to put ready. Okay, great. That was quite a big part about loading assets. I could not have done more simple, I think, or maybe. But anyway, this is great because you can also handle a loading bar or a loading progress, or something like that right from here. And you have a class that handle loading every resources of your project. So now that we have an event when things are ready, the question is, from where do we listen to that event? We could have done it in the experience, and when the resources are ready, we create the world. We can also do it in the world itself. We are going to put it in the world. Why not? It's actually kind of the same result. So here, first, we need to refer to the resources. So just like we got the scene, we can do resources like that. So now we have access to the resources from the world class, because be careful, I'm inside the world class. And what we are going to do now, let me check. Before instancing the environment map, wait, that's it. So right, let's say here, before the environment map, we're going to listen. So these resources on ready. So when the ready event occurs, resources are ready. Let's see if it works. And yes, it does work. So now we wait for the resources. Let's add this comment. From the world, we are listening to the ready on the resources. And now we know from the world that the resources are ready. And what we are going to do now is move the instantiation of the environment map inside that class, just like that. Okay, so we are creating the environment map and everything when the resources are ready. Okay, before it was outside, now it's inside, meaning that when we instantiate the environment map, we can use the resources because everything is loaded. So let's move on. Where and how you listen to the ready event is up to you. So I put it inside the world class. As I said earlier, you could have put it right here, meaning that you don't instantiate the world. You do it only if the resources are ready, but you can also do it inside the classes themselves. Like if you want to create the environment with the sunlight, you can do it. And for the environment map, here inside the environment class, you listen to that ready event and create the environment map when the resources are ready. So it's up to you. A good example is actually my website, where it starts from the beginning. As you can see, as we have a loader, but it's already in 3D. So I'm just waiting for just the minimal assets I need. Then I show the loader. It's already in 3D. And while it's progressing, while I update this part that I already shown, and when everything is ready, I listen to an event that I can show the start button. And when I click on the start button, well, everything is ready from the resources class, and I can start navigating. And actually, the images of the projects are not ready because I have multiple steps of readiness for the resources because the images were quite heavy. So the images are being loaded after. So you can have multiple steps, multiple resources class, multiple instances of the resources class, and you provide different arrays. So it's really up to you. Again, let's keep things simple enough for this project. We have one instance of the resources, and when it's ready, well, we start creating the world. Okay, we are almost at the end. It's getting closer. We did that to have the environment map textures. So that's it. Now, inside the environment class, we can create the environment map. First, we need access to the resources. So just like we retrieve the scene, we can retrieve the resources like that. And then we can call another method, which is going to be environment map, like that. So set environment map. Here we can do that, and then we can do this environment. Oh, it's hard to spell, to type, equal an object. I like to put things inside object, inside properties and everything. We're going to have an intensity for it, so it's going to be 0.4. We're going to have the texture, and the texture, well, we can use it from the resources items. Remember that when sources are loaded, we save them in the items of the resources right here. And the name is the one we chose right here. So that means we need to do this.resources.items and the name we chose, which is, oh, come on, environment map texture. Then why am I saving it there? It's because we need to change the encoding. So encoding to 3.sRGB encoding, like that. Finally, we can add the environment to the scene. So this.scene, we already have access to the scene because we added the light on it. .environment equal this environment map dot texture. So this one right here, and we save. And as you can see, now this part is being in the light of the environment map. So if I remove this, it's in the shade, so it's fully black. And now we can see the environment adding light to the scene. We are not going to put the environment visible behind. I like to have a uniform dark color, but at least it's working on the model, on the objects and everything. At this point, you might have a small bug where the environment map is not working. We are experimenting this in local, which means that the texture are being loaded super fast or even instantly. So what might happen is that the environment map is not working because it's being added after the test mesh, because there are some frames between those and the environment map is not being added to the test mesh. So maybe this part is still dark. Anyway, if you put that online, there are chances that you don't have this illumination on the cube because the environment is added after the cube. What we need to do is update everything in the scene. So let's get into the environment map again, and we're going to create a method to update the scene. So we can put it, let's say after, so we can put it, yes, there. And we are going to do this environment map, and we're going to create a method, update materials, because yes, you can put method inside properties, which are objects inside the class, equal, and we provide a Fatero function. And we're going to traverse the scene. We're going to call this already before I forget, okay, to update it already. You will see why we are putting this inside the function later. It's just handy because we're going to call this one later. And we traverse the scene, so this.scene.traverse. We already did that in a previous lesson, that's why I'm going a bit fast on it. So we traverse the scene. If you log the child, we see that in our scene, we don't have much. We have, well, the scene, the perspective camera, our mesh, so that's the one, and our directional light. If you have more in your scene, well, you will see more there. So again, I repeat, yes, the environment is working, but it's because we are testing in local and it's super fast. For some of you, this part might be still in the shade, so all black. Anyway, we're going to fix that. What we are going to do now is traverse the scene, test if the child is an instance of mesh, and if that mesh has a material that is an instance of the mesh standard material, and then we are going to tell it to use that environment map. So let's go. We already did that before, so we test if the child is an instance of 3.mesh. We already have access to 3 here. And if the child.material is an instance of 3.mesh standard material. Okay, so if it's a mesh and this mesh has a material which is an instance of mesh standard material, then we're going to provide the environment map to it. So child.material.env-map equal, and we provide the same texture that we created before. So this one, we provide the intensity. Anyway, we need that too. So intensity, we have it there. So env-map, let me check intensity. Yeah, that's it. And then we say that this materials needs to be updated with the needs update flag. Needs update equal true, like that. Let's see, and now it's working. And now our intensity is being applied on each mesh too. So even if you didn't have the bug where the environment map wasn't working, Well, at least now we also have control over the intensity. If I put, I don't know, like 2.4, as you can see, it's much brighter. If I put a very low environment map intensity, we can't barely see it. So 0.4 is a good value to start with. Yeah, we put that in a separated, we could have removed this class. See, I'm just traversing the scene at the end, but we're going to call this method later. So that's why we put it inside a separated method. Great. We can add stuff. We have the light, we have the environment map. We can keep adding stuff. Let's add the floor. The floor, if you remember from the initial experience, we have two textures on it. We have the color texture and the normal texture. I can show you quickly in there. So this is the color and this is the normal. So we need to load those, and good news, we can just add them to our sources array. So it's a lot of work, but once everything is working, you are going to be super efficient. So let's go. First, don't forget to put a comma between them. It's a new object. The first one, we are going to name it grass color texture. I should have called it dirt. Anyway, it's not that important. The type is going to be texture, so that is going to use the texture loader. And the path, path is going to be textures.dirt color.jpeg, like that. Okay, I think this one is fine. We can duplicate it because we are lazy. Grass color, so this one is going to be grass normal, and we are going to load the normal. Usually it's PNG for normals, but it's so heavy that I prefer to use JPEGs. We save, and right now we can just check that they are being loaded. If the environment map is working, that means the floor is being loaded, right? And you can check in the network. If you check on the images, can I find them? Oh, it's so small, I can't see much. Yeah, see, we have the environment map being loaded, and we also have the color.jpg and normal.jpg. So it's working great, which means we can create the floor. So let's go. This is a bit exaggerated, but we are going to create a class for that. You don't need a class for only that, but why not? Let's practice a bit. So we are going to create a floor.js class inside the file, inside the Word folder. So let me show you again. Inside the Word folder, we have now the floor.js file. And in this one, it's the same thing. We need the experience class. So we need to move up from one folder, JS. Then we need to export default the class that we're going to name floor. We can call the constructor. Yes, I'm going quite fast, but you know the drill. This.experience equal new experience, so it's a singleton. Then we need the scene. This.experience.scene. And then we need the resources because we need to access the images. Great. I save. Okay, seems good. Let's get back to the console. Pause the video if you need. I'm going to change the file. We go to the Word, and in the Word, inside the ready event callback function, we're going to instantiate the floor. So we do this floor equal new floor, and as you can see, VS Code will suggest this. Yes, that's the file I want to import. I can do that. Don't forget the parentheses, like that. Let's check the floor. Let's do a quick log just to see that it's working. Yes, it is. Great. Pause the video if that was too fast. Oops, resources, like that. So now what we are going to do, it's going to be a bit exaggerated, but we are going to separate each part of the floor. So we're going to create a geometry. We're going to handle the textures. We're going to create the material, and we're going to create the mesh, and we are going to create a method for each one of those. So let's go. This set geometry, set textures, set material, set mesh. Then we can create those right below, like that. Oops, I'm doing some mistakes. Like that. Yes, I went a bit fast. Okay. Pause the video as always, I mean. Okay, great. Now, let's handle each one. The geometry is quite simple. Again, you can just take it from the script. So geometry, floor geometry, yeah, that's the one. New circle geometry, like this. So where is my floor? My floor is right here. So this geometry we save inside properties because we need to have access to them later. Equal that, and don't forget to import Three.js. Import all as 3 from 3. Okay, great. So we have our geometry. That's cool. Let's move on. We need to handle the textures. We can't just refer to them when we create the material because we need to do some stuff on them. So I like to create an object, so textures, and I'm going to handle the first one, which is the color, and I'm going to take it from the resources. So these resources, because we already have access to the resources from here. Items, grass, yes, it's more dirt. I forgot to change it. Anyway, color, texture, and we can just check that we get the texture that we want. Yes, and the name here is the one we chose there. Grass, color, texture, and you can change the name if you want. On that color, we need to do some stuff. First, we need to change the encoding to 3.sRGB encoding, like that. We need to make the texture repeat a bit because it just looks slightly better. You can take that from the script.js file again. We can change the wrap so that it does repeat. 3.repeat wrapping. Yes, I'm going a bit fast again, but we know those and you can copy them from the script.js file. And then we do the same for the normal. So I replace color by normal. We don't need to change the encoding. Actually, it's a mistake to change the encoding. We need to set the default encoding, which is, I think, linear. And it's not the grass color texture, it's the grass normal texture, like that. Let me check. Yeah, sounds good. Anyway, if we do mistakes, we will see them and fix them later. I probably did mistakes here, and you probably saw them. Then we can handle the material. So this dot material equal new 3 mesh standard material. We need to provide an object. The map is going to be this texture.color. The normal map, be careful that it's a M, uppercase M, is going to be the texture normal. We save, still no error. We are almost done. What we need to do now is this dot mesh equal new 3 dot mesh. This dot geometry. We use what we created before. This dot material. Then we can add it to the scene. Let me show you. Scene add this dot mesh, and it's there. Okay, we need to change the rotation a bit. So rotation dot x equal minus math pi, because currently the floor is facing the camera, we need to rotate it, multiply by 0.5, which is a quarter of a full rotation. And this dot mesh dot receive shadow equal true, like that. We can't see the shadow on the cube because of the cube, because the cube is not creating a shadow. So it will work with the fox when we handle the fox. Okay, great. I did a mistake right here. We are instantiating the floor after the environment, but in the environment, we update everything in the scene to apply the environment map intensity. Meaning that if I put, I don't know, like 2, as you can see, it's brighter on the cube, but not on the floor, because this code is being executed before we add the floor. So the floor is not yet inside the scene. Classic mistake. We go back to the world and we first add the floor and then the environment map. And now the environment map is being applied on the floor because the floor is part of the scene. So if I change, let's say the, what is my environment there? If I change the intensity to much higher, as you can see, it's working on the floor too. Okay, great. Let's continue. We created this one, the texture, the material, and the mesh. It's going well. We can add the fox. We can get rid of the cube. I think we get rid of it later, but anyway, we can do it now. So remove the cube like that. And now we need to load the fox. And again, we prepare that in the sources file. Where's my sources file? Right here. We're going to load one more asset. It's actually, I think, the last asset we need. And the name, we can choose whatever we want. It's going to be Fox model. The type is going to be GLTF model, so that it's going to use the GLTF loader. And the path is going to be the path to the model, and it's going to be models /fox /TL. Be careful with the uppercase, so TF, so the T and F are uppercase, /fox.gltf. Let me see, seems good. If I do a mistake, let's see. Yeah, we get some errors. So at this point, if you get an error, just make sure you're putting the right path. Okay, great. Now, again, we're going to create a class. Let's go. In the world, because it's part of the world, so we create a fox.js file. This fox.js file, as usual, so we import the experience from the experience, so it's on the top folder, experience.js. We export the class, so export default class. We did that quite a lot now. So it's not Flux, please, it's Fox. Yes, I'm getting tired. Constructor, this.experience, it's always the same code. New experience, you can copy and paste it from anywhere you want if you think it's faster. This.experience.scene, because we need to add the Fox to the scene, and we need to have access to the Fox, the resource we just loaded, so from the sources, resources in the experience. Let's do a quick test. Let's make sure that we are accessing it. So here's our Fox class. Be careful, I'm going to change the file. I'm going to move to the world.js file, and here it's going to be, I think, right after the floor. Why not? Yes, before the environment, for the same reason as for the floor. We want the environment map intensity to be applied on everything in the scene. So we create the Fox equal new, and I'm going to trust VS Code to import it. So I just write new Fox. Now I can add the parentheses. And as you can see, it added this part. Yes, by the way, we can remove the 3 from the world because we are not using the 3 class inside the world class. Okay, great. As you can see, I have a log. It's the log that I put inside the Fox class. It's this one. It's just to make sure that it's working. Always make sure that it's working. If it's not working, pause the video, fix the bug, and get back to the video. So first, we need to retrieve the actual resource. Set up this resource, singular, equal this resources. So that's our resources class, items, Fox model. It's the name we chose. We can log it to make sure that it's fine. Yes, it is. This is the GLTF that we loaded. Okay. Inside we have animations, asset, camera, scene. Remember from the GLTF, the lesson where we load assets. Okay, great. Save this one in a property because we are going to need it later. It's not the actual model. The model itself is inside the scene property, but we need to have access to other things, which are going to be the animations right here a bit later. That's why we're saving this in a property. So let's create a function. So set model, that we just put the model on the scene. Set model. We're going to save the actual model. So this model equal this resource singular. Okay, that's this one. Resource dot scene, just like I told you. I can show you it again. It's going to be a group. That's the actual model. Then we are going to scale it because trust me, the Fox is just too big if you just add it to the scene. So you can take that code from the script.js file as always. So 0.02, 0.02, 0.02, and we add it to the scene. Scene, add this model. Let me see. And yes, here's the Fox, and it's going well. We are simply missing the shadow. The environment map seems to be applied well because as you can see, this part is not fully in the dark. So that means that the environment map is working. What we need to do now is apply the shade. So there is only one mesh in it, but in case you have multiple meshes, let's traverse the Fox and activate the shadow on every children that needed it. So this model traverse each child like that, just like we did for the scene in the environment class. And if the child is an instance of 3.mesh, we do child cast shadow equal true. And because the floor, oh, I did a mistake. Ah, yes, I'm testing that it's 3.mesh, but I forgot to import 3. I always do. Import all as 3 from 3. That's better. And now we can see the shadow on the floor. The fox is casting the shadow. The floor is receiving the shadow. And now it's working and it looks nice. And the environment map is working. All right. We are almost there. Our fox is not animated. We need to animate that fox. So again, we are going to separate in boxes, more exactly in functions, I mean methods. So set animation. Set animation, we create that method, set animation, like that. And in that, we're going to do this animation. So I like to put things in object, properties, etc. We need a mixer. So those, you can find those from the lesson where we load the model. It's actually the fox that we load and then we animate it. We are going to go even further a bit later in this lesson. You will see. And I think you will like it. 3.animation mixer. So again, I go a bit fast because we already did that. Animation mixer. This dot model. We need to provide the group that is going to handle the animation. This animation mixer, we create, animation mixer. We create the action, so clip action, from the resources. Remember that we save the resource inside these properties because we wanted to access to the animations. Okay, so it's going to be this resource, singular, animations, and we're going to use the first one. Okay, I can show you again. That's the animation. That's the resource. So as you can see, it's the resource, the GLTF once we load it. We have the animations property, and inside we have 3 animations. Okay, we are using the first one, which is, I think, the fox just watching around like that. Okay, then we can play it. This animation action, play. Okay, and it's not working. It's not working because we also need to update the fox on each frame. We need to update the mixer on each frame so that the playing animation is working. So let's go. We know how to do that. We're going to add an update in here. And actually, we are going to start from the experience. Follow me on that. From the experience, we have the world here. In the update, before doing the render, we're going to do this.world.update. So we update the world. If I do that, we get an error because there is no update method in world. So I go into the world, I add the update method. And as I said earlier, we are propagating the update to the children in the order we need. And here we're going to do this.fox.update. But wait, I did a mistake here. At the beginning, the fox is probably not loaded yet. Okay, because we wait for the ready event. So what we can do here is simply test if there is a fox. We could also maybe create a properties on the resource and test that it's ready or whatever. There are many ways of handling that. I like to test if there is a fox where I update the fox. That's all. Okay, now we need to add the update method to the fox. So we go inside the fox class, we add the update. We can do updating the fox, something like that. As you can see, it's updating the fox. Great. Now we can update, which is the mixer. The mixer, we need to do this animation mixer. So that's the mixer we just created. So the animation mixer. Update, and we need to provide the delta time. Okay, it's the time between each frame. But wait, do we have this? Yes, we do. We have the time class, and this is where things get really handy. We need to access to the time class like this, and we can use the, let me see here, time, this time.delta, because we already calculated this one. Be careful, there is a small surprise. Yeah, okay. So it's a druggy fox, we need to fix that. The problem is that our delta is in milliseconds, but the mixer has been made to handle seconds. So calm down, little foxy. We're going to multiply by 0.001 or divide by 1000. Now it's working. Nice, we're almost done. It's looking good. we forgot something. We didn't. But still, it's not done. We need to add the debug UI. Okay, and having classes and modules, etc., we enable cool things about that. So first, let's add a class just for the debug part. So let's go. It's going to be in the utils because it can be used on other projects. It's not part of this specific project. So no, it's debug.js like that. I can show you again. So util, it's debug.js in the utils folder. Inside of this one, not much. We export the default class named debug. We don't need the experience. We don't need event emitters or things like that. You will see that it's going to be very simple. And we do the constructor, and we can do debug started or anything like that. It's just to do a quick test. Then from the experience class, which is right here, we are going to import it. So debug from the utils. Be careful with the path. And then we are going to create it. It's going to be the first one, just in case we need it in the sizes or in the time or whatever classes. I like to start with it. So this debug equal new debug. Finger crossed, debug started, everything is fine. If you get an error, make sure you saved everything, fix the error and get back to the video. We're going to do something cool that I like to do. You can check that on my portfolio. If I do brunosimon.com, like that, I can access my website. Okay, great. But if I add #debug, be careful when you add it, you need to refresh again. Okay, it's how most browsers are working, so you need to refresh again. And as you can see, now I have the debug UI. And that's a feature I think is super cool because all of my websites are like that. I mean, most of my websites are like that. And you can activate the debug on all of them so that you can have fun, debug things, find better colors or anything. And yeah, just like this feature. So let's do this same thing as a bonus. Most users will just access it without knowing that and have the classic experience, but power users, developers, and people that know me can access improved version and have fun with the word and play with the physics or whatever. So to know if there is a #debug on the URL, we can access that. Let me see the debug here. I can log it window.location.hash, just like that. So as you can see, there is nothing, but if I add #anything, I press enter, be careful, you need to refresh. It depends on the browser you're using, but usually sometimes you need to refresh. So I refresh, and as you can see, now I have this. What we are going to do, be careful, there's a slight mistake here. What we're going to do is test that this active is going to be window.location.hash equal #debug. So if there is #debug in the hash, so this is not the case here, it will be true, otherwise it will be false, and we can test it. I can log it. So currently it's false. If I remove the hash, oops, I did a mistake. If I remove the hash, it's still false, but if I add #debug, as you can see, it's true. So now we know that the debug is supposed to be active. And if it's active, well, we are going to create that GUI, an instance of that GUI. So if it's active, we're going to do this UI, let's call it UI, why not, equal new dat.gui, and we need to import that GUI. So import all as dat from dat.gui. It's how we did it earlier. And now it's working. As you can see, I have the debug. If I remove #debug or put something else, it's not working anymore. So access your experience with #debug because we're going to add some stuff there. Okay, great. And that's all for the debug class. Now we are going to add some tweaks, but the tweaks are going to be added inside the classes. All right, this way, if you don't instantiate, I don't know, the Fox, well, you will have no debug related to the Fox. That's the idea. And we are starting with the Fox. That's perfect. As a little bonus, one more bonus, we're going to add some buttons to play the other animations of the Fox, because I had some requests about that, like mixing between animations. Once you export a model with different animations, how you mix between those, like a player that runs and then stays still, and then walk, and then run again. So it's kind of useful to know how to do that. So we'll go on the Fox class right here. And what we are going to do is get the debug class. So let's go. Debug. We can make sure that it's working. Log debug. And as you can see, yes, I have access to it. It's active, and this is the UI. So this thing here. Great. And if the debug is active, so I'm going to add some comments. If this debug active, I'm going to create a folder for the Fox. So this debug folder equals this debug UI. So that's my .gui instance. Add folder Fox. And now we have a folder for the Fox when the Fox is being instantiated. Great. We are going to add some tweaks to it. We can add them like after creating the model and animation right here in the constructor, but I like to put the tweaks related to each part of the class. So if I need to add some tweaks about the scale, I'm going to add those tweaks right here. If I need to add some tweaks about the animation, I'm going to add them here. So hang on, this part is a bit hard about how to play multiple animation and mix between those animations properly. First, we need to prepare the actions, because right now all we have is one action that we save in this action property, and we already played it. So let's do some structuring changes. First, we need to do, let's get rid of this one, the default action. We need to prepare the three available actions. So I'm going to do this animation actions with an S equal an object. Then I'm going to create the first one, and I'm going to choose a name, which is going to be idle. Okay, I know those different animations. The first one is the one you can see here. The second one is the Fox walking. The third one is the Fox running. So idle, and we do the same thing we did earlier. So this animation, I should not have removed it. Clip action is going to be this resource animations 0. Okay, it's kind of the same code, but I'm putting it inside the actions idle, and I created the action object right before. So I have the idle, I can do the walking, and I can do the running. For the walking, it's not going to be the 0, it's going to be the 1, and for the running, it's going to be the 2. Okay, great. So now the Fox is not playing anymore because we removed the play 2, but I have all three animations ready. We can decide on the current ones. What we are going to do is create actions.current, and we are going to decide that it's idle or walking or running. Okay, you can change it to whatever you want, but I'm going to use the idle one as the default one. Okay, it's just that I put the idle one in a property named current. This will get handy a bit later, and now I can play it like that. So we got back to what we had before, but right now we have all three animations ready. If I want to play the walking by default, I put walking here, and he's walking. If I want to put running, and now he's running. Okay, great. So let's get back to the idle one, kind of the default one. We want the animation to change between the different animations smoothly. I don't want it to jump straight to the other animation. I want a mix, a clean mix between the different animations. And we can do that with the many methods provided by the animation action class. All right, we have many methods to fade the animation. So it's not about the alpha, it's really about the animation itself. We can fade the animation, we can cross-fade the animation, we can start from one to another, or start from the other to the current one, or whatever. There are many animations. We are not going to test all of those, of the possible ways of doing that. We're going to use a default one. We are going to use the cross-fade from. This method needs to be called on the incoming action. So if we want to walk, we are going to call that on the walk action. And we are going to provide the previous one as the parameter. So it's a bit weird. We could do the opposite, but I would like to show you this one. So if we want suddenly our Fox to walk, we're going to start from this one. We're going to call the crossfade from on this one and provide as the parameter the current one. And it's going to crossfade toward that animation, and you will see that it will go from idle to walking or idle to running, and later we can change to something else. So if he was running, we're going to go from running to walking or idle, and you will see that it will be a clean transition between those. And the second parameter of the crossfade from is the duration of the transition, and it's in seconds. All right, just keep in mind that those are seconds. We also need to reset and play the new animation. This is a bit weird. I don't know if they forgot something or I did something wrong, but you need to reset and play the animation you want to go to. So if you want to walk, you need to do the crossfade just like we said, but you also need to reset and play the walk. All right, that's why it's a bit tricky. As you can see, we need to do quite a lot of things. We're going to put that in a property, in a method. So let's go. This animation.play, and we are going to say I want to play the name of the animation. So we are going to provide idle, walking, or running. So it's going to be a fat arrow like that. And in that animation method, first I need to make sure that I know which one is the new action and which one is the previous action. So const new action, I mean the old action, previous, old is kind of the same. So the new action is, well, it's the one that we ask in the property here, in the parameters here. So it's going to be this animation actions. So this is my actions. And we want to play, let's say, this one. So if we provide idle here, we are going to get this one as the new action. If we provide walking as the parameter, we are going to get this one. If we provide running as the parameter, we are going to get this one. So that's the new action. We need to know the previous action, so I'm going to call it old action, and it's going to be the current action. Okay, so this animations actions, animation singular actions dot current. Okay, it's the previous one. We're going to update the current right after, but if at the beginning of this method you want to know which one is the old action, well, actually currently it's the current one. Okay, great. Then we need to, as I said earlier, reset and play the new one. So we do new action, reset, and new action, play. And finally, we can do this famous crossfade. So we do new action, crossfade from. So we start from the new action and we say we want to go from the old action as a parameter, and it's going to last 1 second. Okay, so for 1 second it will go from the old action to that new action. That's great. Finally, we need to save so that new action as the current one. So this animation actions.current equal new action, so that the next time we call this method with another one, the old action will be the one that was playing right now. Whew, that was a lot. Okay, might have done some mistakes. We need to test that. How can we test that? That's a good question. I mean, should we already add it to that GUI? We've been coding quite a lot without testing. It's going to be long to add it to that GUI. How can I test it? That's a good scenario. Remember that we added the experience to the global scope. We can do window, experience. You need to remember kind of your structure. So experience, world, fox, animation, and now we can use the play. See, it's our structure and it all makes sense. So it's the animation play, and we can provide, I don't know, like walking, and check that when I press enter and he starts to walk. And it took 1 second to go from idle to walk. And we can try with running, and now he's running. We can go back to idle, and now he's idle, and we can go back to running like that. The purpose here is just to test it fast. Okay, that's why I like to have the experience available in the global scope in the window. I can do fast tests. Great, but we want it to be added to that GUI. That was the purpose of it. We can add the debug button to our Fox debug folder. So let's go. Let's do that. Remember that the debug folder is right here. We created it here if the debug is active, which is the case here because we have hash debug. So we're going to add some buttons here, but we have an issue. We can't add this function, this method, to the folder as just a button, because when we call that function, we need to provide a name. We need to provide, a parameter, the name of the action. So we can't just provide them to that UI, because that UI, you just provide the thing to call, and you can't say, I want to call those parameters when you call this function. So it's a bit weird. We need to do the trick we used earlier by using a debug object. Follow me on that. Right after creating this whole thing for the animation, we're going to add a debug part. If the debug is active, always state that the debug is active, because you don't want to add things to a debug that is not here. We're going to create a debug object like that, which purpose is just to exist, okay? Play idle. It's a function that will do the idle animation, that will play the idle animation, play idle. And the idea is that we are going to call just debug object play idle in our .GUI, and it will do that, because we can't provide parameters to .GUI. That's an issue with .GUI. We can do the same for the other ones. So play idle, play walking, and play running, like that. You can remove this trailing comma, and now we can add those to, we could loop through them, but let's be a bit lazy. This debug folder, remember that that's our Fox folder, add debug object play idle. All right, that's this property name right here. And as you can see, we can't provide a parameter. That was the issue, but right now we don't have any parameter. This function will be called, and this will be called. So it's going to play the idle function. Yeah, that's a bit far-fetched, but unfortunately, I don't think there is other ways of doing it. Other clean ways and easy way of doing it. I know another way, but it's even worse, I think. Like that. So let's see. If I check on the Fox, you need to open it. Play walking, and now it's walking. Play running, and now it's running. That's great. And we can control it. Okay, cool. We are almost done. Let's add a bit more of debug to our tweak. And we're going to do that for the environment. Quite an easy one. The next debugs are going to be easy. We are just practicing it in other classes. It's always important to have a good debug UI, very complete with everything you can have in it. Maybe not everything, but a lot of things, so that you can find the right tweaks and debug your experience fast. The faster you are, the more efficient you are. Let's do it for the environment. So same thing for the environment. Let's go on the environment. First, we need to retrieve the debug instance. So debug on the experience. If it's active, so like that, debug. If this.debug.active, we create a debug folder and we save it as a property. This debug UI add folder environment, like that. Now, as you can see, we have the Fox and the environment. Okay, cool. Now we are going to play, I think, just with the intensity, right? Yeah, that's it. So I'm going to move to the environment map method so that everything is in the related box. So debug, if, so it's a bit redundant, but if this debug active, so if the debug is active, we're going to add a tweak. So if you remember, it's going to be this debug folder. You can take this one, almost everything from the script.js file. So debug folder, we're going to add, so it looks like that, this environment map. Oh, that's weird. Oh, what did I do? Oh, that's an issue. Okay, I did a mistake earlier. We'll add an annotation, so we probably already saw the annotation. This is environment map, not set environment map. That was actually a huge mistake. Anyway, it was working. So in this environment map, we're going to tweak the intensity property. So this one, so we can already save, I guess. Let's see, environment. Yes, we have it, so we can tweak it. But we need to add more stuff, so we can change the name to something more efficient. So env map intensity, not too long because we don't have much room on the left. So now the name is a bit better. Great. We can have a minimum value to 0, a max value to 4, and a step something like that, quite precise. And when the value changes, because right now if you test it, check that, I change the value, it doesn't change anything because we are changing this property, but this is just like a lost property that is not being used anywhere. So we need to update all our materials, and we actually already have it right here. That's why I told you to put it inside a method that we can call easily. So when the value change, well, we already did that earlier. So when the value change, we call this environment map update materials. And now when you change the intensity, it's not working. Oh, small mistakes again. I put update material. It was update materials. So you can remove the S here or add the S here. I will add the S here because it's multiple materials to update. 2 mistakes here. Sorry for that. I hope you saw the annotation on the video. So we change the intensity, and now as you can see, we are changing the intensity of the environment map, and it's changing for all the assets in the scene because we are looping through the scene. We are traversing the scene. That's great. Let's add one more group of debugs, this time for the sunlight. So let's go. We do the same. Let's get even more lazy and take this part here. Like that. And we are going to add some stuff. So this debug folder, and we add again, so add, it's on the sunlight, which is an instance of directional light. We are going to play with the intensity. The name, we can change it, sunlight intensity. We can put the min value to 0. We can put the max value to 10. We can put the step to the same as the environment map. And let's see if it's working. We don't need to listen to the on-change. We can just, oh, never mind, it's not this one. Okay, that's in the sunlight intensity. So I put this one to 0, and now it's working. Okay, that's cool. And now we can do the same for the position. So let's first focus on the X. So this sunlight position X. So it's the X property on the position of the sunlight. Name sunlight X. Why not? Between -5 and 5. That should be enough. And as you can see, now I can control the sunlight X. Let's be lazy, duplicate it. Why are you doing that, VS Code? For the X, the Y. And we can name it Y. And we can do the same for the Y. I don't get this update here. On the Z, like that. And now we can tweak the X, the Y, so it's a bit weird to have it below, but anyway, it's possible, and the Z, like that. And it's looking great, and we can control everything. That's cool. We are kind of done, but I want to show you one more thing, and I get this question a lot too, how to destroy things. Yes, that's important, because at some point you might need to destroy parts of your experience or even the whole experience. Many reasons for that. Maybe the page, you scroll the page, you need to destroy the WebGL experience, or maybe you change the page, or maybe you have, I don't know, a level where the player is playing, and then the player wins, he goes to the next level, then you need to destroy what was on the previous levels. You don't want to let things that you don't see on the screen anymore, that you are not sure you're not going to use, because it's bad for performances. There are things that just runs in the JavaScript, so that's kind of bad, but it's not that bad. But there are also things that are being loaded on the GPU, and you need to clear those as much as possible. You need to remove things that you don't use anymore. We are talking about disposing of things, destroying things. Here we are going to destroy everything. Okay, it's going to be quite a good example. So first, remember that we have time and resize events. If you want to destroy everything, well, you don't want to be alert that the time is ticking and the resize is occurring. So we need to stop those. First, in the experience class, and we're going to put actually everything there about destroying, you create a destroy method like that. And in here, you're going to do this.sizes, and it's going to be off resize. Okay, that's one of the methods of the event emitter. We saw the trigger on, and now we see the off. And when you provide the off like that, it will remove every listener on this event name. And remember that it was that name we were listening to. So we can do this one, and we can do the same for the time, and the name is going to be tick. Okay, so we save. And when we call destroy, so you might ask, what's that? Okay, by the way. Oh yeah, I forgot to remove it from the environment, I guess. Yes, we can remove this one. That was just a test. So from the console, we can do experience.destroy. Okay, we are calling that ourselves because there is actually no purpose, but it can be another developer. Once the page is gone, the user has switched to another page where we need to make sure to destroy the experience properly. So the other developer will call the destroy method of your experience class. Okay, great. So destroy, and as you can see, everything seems to have stopped. It's not a bug, it's just that we are not listening to the tick event, and the request animation frame, well, is not doing anything anymore. So we are not updating the class anymore, and that's a good start. But we need to go further. What we need to do now, yeah, by the way, I didn't write window, it's implicit. Yes, that's weird, but you don't need to write window. You can just do the same with or without window. How to dispose of things in the scene. That's not that easy. We are going to traverse the scene and look for things that we want to dispose. First, let's traverse the scene. So we're going to do traverse the whole scene, something like that. And then we're going to do this.scene.traverse child. So we want to get every child, and we're going to log that. So when we call the destroy method, as you can see, we have quite a lot of things. We have bones that are part of the fox. We have meshes, the camera. We have many things here. So what do we need to dispose exactly? Actually, there's a page on the Three.js documentation. This was a bit too hidden, which is the how to dispose of objects. And you should read that page. There are a lot of interesting things here. I'm going to tell you the main part of it on how to dispose of things. The main idea is that we need to dispose of geometries. We need to dispose of materials, textures, very important, this one, and specific things like the controls, passes, and other things like that. And it depends on what you have in your project. Okay, it really depends on the project. So we are going to kind of try to cover everything, but it really depends on your project. Okay, the idea is that we are going to do that for each children. First, we test if it's a mesh. If it's a mesh, we call the dispose on the geometry because every mesh has a geometry. So we are going to call dispose on it. Then we are going to loop through every keys in the material of that mesh and check if there is a dispose method on it. Why? Well, because if you remember from the material, let's take the mesh standard material, you can have maps. You can have the map, normal map, environment map, roughness map, metalness map. You can have many maps. So it's hard to cover all of them, test all of them. What we're going to do is test all keys, all properties of the material. And if there is something with the dispose method, we just call that dispose method. That's the idea. It's a bit rough, but it's efficient. Okay, so let's go. First, if child is an instance of 3.mesh. We test if it's a mesh. Then we log the child. Then we call the destroy. Don't forget to call the destroy. And as you can see, we get two of those, which is the floor and the fox. Okay, cool. In a bigger project, you might have a lot of things there. First, we can do child.geometry.dispose. We know that we can do that. There is a geometry on each mesh, so we dispose of it. And we call it. That's great. It seems that it's working. Then we are going to loop through every key of the material. So key in, it's not off, it's in child.material. And you can log it to check what we get. And you'll see we get quite a lot of things. We get all those properties on the material. Yes, there is a lot of properties on the material. Then we can retrieve the value, const value equal child.material.key. And in the value, we are going to get a lot of things again. If I call the destroy, as you can see, I get a bunch of things related to the material. And we get those: cube texture, texture, maybe more, let me see, cube texture again, texture, texture, and those are the ones we need to dispose. What we are going to do, kind of rough, but if there is a value and type of value.dispose is a function. We test if there is something in the value and that thing has a dispose function. If it's the case, we're going to call value dispose. So we are disposing of things that can be disposed of. So that's the idea. Now we call destroy, and supposedly things have been destroyed properly. That's the idea. Yes, I'm not a big fan of that, but disposing of things is a bit hard and you need to do some tricks like that. Yeah, be careful, you might have things different for each project. Also, we need to do that for the controls, because yes, the Orbit controls class do have a dispose method. You need to check everything you have. Dispose, yes, there is a dispose method in the Orbit controls class. So let's go, quite easy. We can do this camera controls dispose, like that. We call it, just to make sure that there is no error. Yeah, okay, great. It's actually removing events on the canvas and things like that. The renderer, same thing. If you check on the WebGL renderer, there is a dispose method. So we call this one. This renderer is in the instance property, dispose, and we test. It takes time to find everything you need to dispose. By the way, small warning, if you are using post-processing, so effect composer, specific passes, and all things like that, you need to dispose of those. And you also need to dispose of the WebGL render target inside the effect composer. So we are not using those, so I'm not going to show you that, but I have to warn you about that. The debug, yes, we still have the debug, though it's not doing anything because we dispose of things and it's not being updated, but we can do that too. First, we need to test if there is a debug, so this debug active, and we are lucky here, that UI, you can just do debug UI destroy, like that, okay? I call the destroy again, and as you can see, it's gone. So this one is clean. Okay. That's all for the destroying part, but I have some stuff to tell you about those. Destroying things, as you can see, is a bit tricky, and you need to dive into the different components and make sure that you are disposing of everything properly. Go through your code and check, do I need to dispose of that? Do I need to dispose of this? And continue like that and make sure you are doing it properly and call it to be sure of that. We didn't remove the canvas, as you can see, it's still on the page, but it's not doing anything. What we are seeing here is just the last render. If you want to remove the canvas, please do, but it's not that important because it's not doing anything. That's just like an image. We stop listening to the sizes and time events, but those are our classes. Inside those sizes and time events, we are listening to things like window, add event listener, resize. So we are not going to cover that, but if you are a bit picky, you might want to remove those too. Okay, so you need to do remove event listener. I'll let you do that. It's a classic JavaScript. We wrote everything inside the destroy because there is not that much things to do, but for a more complex project, you might want to create a destroy method on each class, and then each class will destroy itself properly. All right. Again, I try to keep things simple, but usually I create a destroy method on each class, on the Fox, on the world, on the renderer, on the camera, etc. And the destroy here will call the destroy of the subclasses, just like we did the update on the subclasses from this one. Okay. That might look hard. See how long it took to get this working, and counterproductive at first, but in real life, Three.js project can end up being so huge that you better not have spaghetti code, all right? A big client project can be like thousands and thousands of lines of code. You can't put everything in one file in spaghetti. You won't be able to finish the project because it's going to be a mess. You need to organize. That's why I'm using this kind of structure. Having these separated classes is also great for reusing them in other projects, like the time, sizes, everything in utils, or even if you want to use the Fox on another project, you can. Structuring code also creates a good environment in which to work with other developers because each one can work on a specific class. As I said at the beginning, many of the decisions we made during this lesson are specific to my personal preferences. Maybe it's too much, maybe you would have done things differently, and please do take what's good from what I just shown you and do your own version, and please share that version with other people. You can put it on a Git, GitLab or whatever and share it with the community on Twitter. I will be glad to see your own templates, and I will see you in the next lesson.